Python is a popular general process programming language. The Python software foundation continues to develop itself. Its syntax was designed with code readability in mind, letting programmers to express themselves with fewer lines of code. This course is designed specially for people who are new to programming and wish to learn the fundamentals. So why wait? Let's get started and learn Python programming through this course. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments. Now very quickly, let me walk you through the agenda of today's course. In today's course, we are going to look at Python's basic concept, Python practice code, Palindrome in Python, Factorial program in Python, Fibonacci series in Python, leap year program in Python, prime number program in Python, GCD of Two Numbers and Tic Tac Toe Python.
Now let's start with what is Python, right? Python is a popular high-level object-oriented and interpreted language. Right, so let's talk about what is Python who has no idea about Python, right? You have no idea what is Python and why do we use it, right? So let me give you a quick introduction to that and then we will jump into the code part. So Python is high-level and also we are saying that it's a popular language. Basically, in the layman term, if we can say, okay, if you know English in a proper way how to write the English, then you can start writing Python. You will say, is it that easy to do that? And why do we need it? We need it because we do communication between the human beings. But if you want to talk with your computer, how can you do that? How can you communicate with your computer and just, say your computer, please do something for me. All right. How can you do that? To communicate with your computer, you need to have a language and also they have a grammar, right? Those grammar are nothing but the syntax we have in the programming languages, right? Okay, so in this particular case, what we are going to do, we will use Python to give a command to our computer. And the main thing about Python, you don't need to have lots of syntaxes to remind. What you need to have, you need to have a proper indentation. What is indentation? I will talk about that. So let's have a look at the bullet point we have. Now we say what is Python and this is something high level. High level means we know if you want to actually talk give some instruction to your computer, we need to go to low level language. The binary language you can say. But in the case of Python, you don't need to take care of low level language. You can directly write your command in English and it will understand, right, by the Python interpreter. Now comes object-oriented. Some of you said, I want to learn object-oriented. What is object-oriented? Object-oriented is basically, you can say this is a feature for a programming language. There are lots of things comes into the picture. And if you really want to learn about object-oriented programming, then why don't you check out our full course on Python, where we have talked about everything you need to know for object-oriented programming, right? Then we have said that Python is interpreted. Yes, it has an interpreter which can interpret what you are saying, right? But yes, you have to maintain the indentation. Now comes, why do we need Python? Why Python is becoming popular these days, right? One, it is simple, beginner friendly. If you are someone who has never done any programming language, you are not from a computer background, then also Python is for you, right? And you will not feel bored basically with Python. You will get lots of good, good, cool library you will get, and using those library, you can do really cool stuff and you will feel, oh my God, this programming language can be this much interesting, right? You don't need to deal with lots of lines of codes, right? The main attractive, feature of Python is you don't need to write a long line of code. You can, suppose you need to write or you need to print maybe hello world, right? For the case of C++, Java, at least you have to write, 3-4 lines of code. But in the case of Python, you just need to write one line of code, right? Okay. So these are the basic features of Python you can see. Now, if you're coming from a web development background, if you are not from a data science background, then also Python is for you, because there are lots of library you will get in Python, right? You have Django, you have Flask, right? That will make your life easy. Now, why Python is getting the popularity? The main reason behind it, it has lots of library which will make your life easy. We will see some of the library, how it's going to work, but let's see how we are going to progress with this Python one.
So let's start off by installing Python, and we can install Python from this website over here, www.python.org. So I'll click on this. Alright, so you see that you have the latest version of Python over here, Python 3.8.0, and you can download the Python version with respect to whatever operating system you're using. So if you have a Windows system, then you can download Python for Windows. If you have a Linux or Unix system, then you can download Python for Linux or Unix. And if you have a Mac operating system, then you can download Python for Mac operating system. And since I have a Windows system, I'll download it for Windows. So I'll just click on this over here, and you see that the download has started. Right. So now I actually have Python installed in my system. So once the installation of Python is done, we need something known as an IDE. So IDE basically stands for Integrated Development Environment, and Integrated Development Environment basically makes your work much easier while programming. So it gives you certain prompts, and you have all of the tools present in the IDE. And one such IDE which is very famous for Python is PyCharm. So we can install PyCharm from the site over here, jetbrains.com/PyCharm. So let's just wait till the site opens up. Right, so you have the download button over here. You just click on this. And for our programming purpose, we'll just download this community version over here, right? So for pure Python development, you click on download and the download would start. And again, since I'm using a Windows system, so this is for the Windows system over here. All right. Now, Anaconda is a Python distribution which basically provides you all of the packages inbuilt. So you have packages such as matplotlib for visualization, pandas for data manipulation, and numpy for numerical computing. So you don't have to manually install all of these packages. So when you actually install Anaconda, all of these packages are actually pre-installed in Anaconda. And for doing all of your coding, you have something known as the Jupyter Notebook. So first to use a Jupyter Notebook, we would need Anaconda. So let's go ahead and install Anaconda. Right, so this is anaconda.com, and I'll just click on download now. So we need the Anaconda distribution, and again I'll click on download, right? So we've got Windows, Mac OS, and Linux, and this is the latest version of Python 3.7. So that is what we had downloaded earlier. So this was the older version of Python 2.7, but everyone has moved on to Python 3.7 now, and that is why we'll also be downloading Anaconda for the latest Python version, which is Python 3.7. So it'll automatically start the download for 64-bit operating system. So once the download for Anaconda is done, we need something known as the Jupyter Notebook, which I've already told you. So as it is written over here, Jupyter Notebook is basically a browser-based interpreter that allows us to interactively work with Python. And this is how your Jupyter Notebook looks like. So let me go ahead and open up Jupyter Notebook. Right, so let me open up Anaconda prompt first. So I'll type in Anaconda prompt. So this is the command line interface. Now to open up Jupyter Notebook, I'll just type in Jupyter space notebook, and let me wait till this opens up. Alright, so this is the Jupyter Notebook over here, right? And this is how it looks like. Now to open up a new notebook, we just have to click on new, and we'll click this new Python 3 notebook, and we have successfully opened our new Python notebook. Let me just rename this to Python programming. Now once this is done, let's go ahead and write our first Python program. So we'll just use the print statement. So you just have to type in print, and inside this I'll type in, let's say, this is Sparta, and all you have to do is click on run, and you have your first program ready. You have successfully printed this is Sparta on the console. Well, you've just taken the first step to hacking NASA, right? So you just have to take the baby steps and you'll be an expert at Python programming, and you have successfully started with your first Python program. So now that we have written our first Python program, the question which needs to arise in your mind is, every programming language needs to deal with a lot of data. So where do we actually store this data? Well, this is where variables come in. So let's say you have to store the names of all of the students present in a classroom. So let's say the names are John, Sam, Matt, Bob, Anne, Julia, and so on. And you have 50 such names. And you have to store all of these names somewhere. So how do you do it? Well, all you have to do is take a variable and store all of these names in a variable. Now, you must be thinking, what exactly is a variable? So let's understand that with this example. So simply put, variables are basically temporary storage spaces where you can store data or values. Now, let's take this example over here. So consider this folder to be a variable. So what you do is you store this value temporarily inside this folder. So this value is John, which is the name of the student. So you take in this value and place inside this variable for a certain amount of time. Now after that, since this is only a temporary storage space, you can take out this variable and replace it with Sam. Right? So now this variable holds the value Sam. And after some time, again, you decide that Sam is not the name which I want to store and I want to store the name Matt. So again, you take out the name Sam and store Matt inside this folder. So this is how variables work. They are temporary storage values where you can keep on changing the values inside it. So now that we know what exactly are variables, let's go to Jupyter Notebook and work with variables. So again, I'll open up a new Python 3 notebook over here. So now to assign a variable, I'll just create a new object over here and I'll name it as var1. I'll use the assignment operator and I'll give in the name. So the first name would be Bob, and to print it out, I'll just type in var1 over here again. Right, so we have successfully stored the value Bob inside var1. Now I'll change the value inside this variable. So what I'll do is I will actually store the value Sam inside this var1 and let me print it out again. So now var1 stores Sam. So initially var1 had the value Bob and after some time I had replaced the value with Sam. Now again, let me change the value. So inside var1 I will be storing Matt and let me print it out again. So this time it has the value Matt. So as you see, variables are just temporary storage spaces where the values can be changed. Now every variable is actually associated with a data type. So there are different types of data which a variable can hold. It can be of integer type, it can be floating or decimal type, it can be a boolean, it can be a string. So when it comes to integers, so you basically have numbers such as 10, 500, 1000, -10, -27 and so on. And floating are basically decimal point numbers, so 3.14, 15.97 or -2.1678. So any such decimal point number would be a floating point number. And then you've got Boolean values or basically logical values, and true and false are basically your Boolean values. And then you finally have the string values. So a string is basically a set of characters enclosed together, right? So Sam is basically a set of characters, it is a string. And then you have Matt, which is basically a set of characters, it is a string. And strings are generally enclosed within double quotes, single quotes, or triple quotes. Right, now let's assign some different types of data to our variables. So let me create a new variable A and I'll store the value 10 inside this. Now I'll go ahead and check the type of this. So the type of this variable would be int. Now inside A, I'll actually store a decimal point number. So this time I'll store 13.4 and then let me check the type of it. So type of A, again I'll click on run. So this time we see that there's a floating point number. So what you can basically notice is the type of the variable would depend on the type of the data which you are actually storing inside the variable. So if you store an integer type data inside the variable, then the type of the variable would be integer. And if you store a floating point or a decimal type data inside the variable, then the type of the variable would be floating type. Now similarly, let me go ahead and store a Boolean value inside this. So I'll store true inside this. Let me check type of A. So the type of A is bool. Now let me store a character value. So I'll type hello world. Let me remove out this W over here. And then again, I'll check the type of this. So type of A. And then the type of A is string. So finally, we have one more type of data, which is basically complex number. So complex numbers, you basically know that it has a real part and an imaginary part. So let me just type it out. So 4 plus, let's say 8j. Now, normally in mathematics, it is actually represented as 4 plus 8i. Now, when it comes to Python programming, we represent the imaginary part with j. So 4 is the real part over here and 8j is the imaginary part over here. So just to confirm it, I'll again check the type. So type of A, the type of A is complex. So all of these are the different types of data which we can work with in Python.
Now we are going to talk about what is conditional statement. Some of you are saying, I want to learn about loops, right? So how to start with loops and when to start with loops. There is a big difference between loops and conditional statement. We use conditional statement like if, else, and for loops we use for loops, while loops, right? So you have to understand the difference between conditional statement and loops. Suppose for the conditional statement, what we have, suppose you need to take up, decision. If it's raining, then I will sit inside. If it's actually not raining, then I will go out and play football, right? So this is why your if statement comes into the picture, and if else is known as conditional statement. So if you go for an interview in Python, do not say if and else is a loop. It's not a loop, it's a conditional statement, right? Okay, now if I show you what is that, actually how can you implement that, right? Let me make few more cells here. Okay, now let me write it down. Suppose I am going to say if, let me take a input. So one more thing, how to take a user input using Python, right? So suppose you are going to use an input function here, okay? And here, if you just say enter the weather, and you are going to write A is equals to input, enter the weather, right? So what it will do, input methods is going to take a input from the user. If you just execute that, it will say enter the weather. Can you see the message you have written over here? Yes. Now if you say it's rainy, right? You have written that it's rainy. Now if you just write A, it will print what? Can you see? It takes the user input. Yes, this is how, this is how we actually take the user input. The most important question for whatever language you are going for the interview, they will ask you, can you take a user input? Yes. Most of the time, if you are going to make a website, if you are going to work with data science, many of the time you have to take user input. How to take that user input? So basically, you just need to use input method for the case of Python, and you can write rainy, right? If you just write rainy, and if you check after that, can you see the A actually captures the user input. Now I will actually going to write an if statement. I am going to write if A equals to, I'm going to write rainy, then print stay inside. Can you see what is actually printing? Stay inside. Now I will explain you what is A equals to and this, right? This equals to basically matching the string. So basically this A is what type? If I just write type of A, right? So what type it is? The type is string. So if you want to match a string, how to do that? You have to write if A equals to rainy, then print stay inside. Now if you are just going to write else what? I'm going to print let's go and play football, right? Now in this particular case, what we are going to write? Now if you are going to write is sunny, right? Now if I just do the same thing, what you can see, it's a string type, and if I just execute this, can you see what I get? I get let's go and I have to write play football. I get a answer that let's go and play football. So if you can look over here, when my string is not equals to rainy, right? That's why it comes to this part, else part. It's a condition making, right? It helps you to take your, take a decision, right? So this is your condition. If it's rainy, if the weather is rainy, then I will stay inside. Otherwise, I will go out and play football, right? Yes. So in this particular case, you can say, let's go and play football. Why? Because here A equals to, I just write print A. So print A equals to, this is sunny. Can you see? Yes. So this is how we can actually implement conditional statement, not loop.
Now let's head on to looping statements. So looping statements are basically used to repeat a task multiple times. So let's understand looping statements with this example. So you have a bucket and you'd want to completely fill it up with a mug of water. So the condition is, while the bucket is not full, you will keep on adding a mug of water to it until it is full. So here the repetition task is, you will have a mug of water and you will keep on pouring that into the bucket until it is full. So you're repeating a task until the final condition is met. And this is how the while loop works. So, and in looping statements, you basically have while and for. So we'll start with the while loop. So let's go to Jupyter Notebook again. So let me initialize a variable first. So I'll type in I equals 1 and then I'll use the while loop. So the condition would be, while I is less than or equal to 10, I'd have to print out I. Now after this is done, I have to increment the value of I with 1. So let me print this out. So this is the result. Now let's understand this better. So initially I have a variable I and I have initialized it with the value 1. Then I'll start this while loop. So over here, I'll check if I is less than or equal to 10 and initially I's value is equal to 1. So is 1 less than or equal to 10? So it is true. And since this is evaluated to true, I'll come inside the while loop and I'll print out the value of I, which is 1. Then I'll increment the value of I. So 1 plus 1 would become 2. Again, I'll check if 2 is less than or equal to 10. And since 2 is less than or equal to 10, I'll again come inside the while loop and then I'll print out 2. Then again, I is incremented, I's value would become 3. So I'll check if 3 is less than or equal to 10. Again, it evaluates to true, I'll print out 3. And then this loop repeats itself until I's value becomes equal to 10. Right, so the final value would become equal to 10 and then I's value would become 11. So here I'll check if 11 is less than or equal to 10 and that condition would fail. And when the condition finally fails, we will come out of the loop. So this is how the while loop works. So now using the while loop, I want to print the 2 table. That is 2 cross 1 equals 2, 2 cross 2 equals 4 and 2 cross 3 equals 6 and so on. So I'll have the first variable initialized, which is I equals 1 and then I'll type in n equals 2. So I have my variables initialized over here. Now I'll start the while loop and this loop will go on till I's value is less than or equal to 10. Now inside this, I want to print out, so n and then cross I is equal to, I'll just put in n cross I. So let me print this out. So after this, I have to actually give in one more condition, which is I equals I plus 1. So if I don't increment the value of I, then it will go into an infinite loop. So I'll hit run. So we have this 2 table over here. So let me explain this properly. So initially I's value is 1. So I'll check if 1 is less than or equal to 10, which is true. So I'll come inside this and I'll print out 2 cross 1 is equal to 2. And then I'll increment the value of I, which is 2. Then I'll check if 2 is less than or equal to 10, which is again true. Then I'll come inside and then I'll print out 2 cross 2 is equal to 4. Then again, I's value is incremented. It becomes 3. Then I'll check if 3 is less than or equal to 10. And since this is true, I'll again come inside and then I'll print out 3 cross 2 is equal to 6. And this goes on until the I's value is equal to 10. And then I'll print out 2 cross 10 is equal to 20. And when we increment I's value again, it becomes 11. So is 11 less than or equal to 10? Well, it evaluates to false because 11 is greater than 10. Right, so this is where the loop ends and we have the final value, which is 2 cross 10 equals 20. Now let's use while loop with a list. So I'll basically create a list with a bunch of elements inside it, and with the help of while loop, I want to add 100 more to each of the value inside the list. So let me create the list over here, L1, and I'll add in a bunch of values over here. So 1, 2, 3, 4, and 5. So the list has been created now. Now I'll go ahead and initialize the variable I to be equal to 0. So this is also done, and then I'll start the while loop. So inside the while loop, I will basically check till I is less than, so let me remove these brackets over here. So while I is less than length of L1. So length of L1 would be 1, 2, 3, 4 and 5. So I would go from 0 to 4. And then I basically want to increment each element inside this list. So L1 of I would be equal to L1 of I plus 100. And then I also have to increment the value of I. So I would become I plus 1, and then finally I'll print out the value of L1. Right, so initially the values in the list were 1, 2, 3, 4 and 5, and after running the loop the values became 101, 102, 103, 104 and 105. So let's understand this loop. So initially value of I was 0, and I'm checking if 0 is less than 5, which is true. So I'll come inside and I'll assign L1 of 0 to be equal to L1 of 0 plus 100. So it'll be 100 plus 1, which is equal to 101, right? So 1 would become 101, and then I's value is incremented by 1. So I's value is 1 now, and then again I'll check if I is less than 5, which is true. So I'll come inside and then I'll assign L1 of 1 is equal to L1 of 1 plus 100. So I'm adding 100 to this element 2. So it becomes 102. And similarly, this will go on till index number 4. And when it becomes 5, so 5 is not less than 5. And that is when we'll come out of this loop. So this is how we can work with the while loop. Now we'll head on to the for loop. So for loop is used to iterate over a sequence. So that sequence could be either tuple, list, dictionary, set, or even a string. And this is the syntax of for loop. So for value in the sequence, and then we'll give out the body. Now this might seem a bit vague or difficult to understand. So let's directly head to Jupyter Notebook and go ahead with the code. So let me start off by creating a list. So I'll type in L1 equals, and then I'll give in a bunch of colors inside this, which would be equal to blue, green, and then I'll just assign red to it. Now, once this is done, let me use the for loop and iterate over this list. So for I in L1, I'll just print out I. Right, so I have printed out each individual element of this list. So for I in L1, right? So when I say I, this value of I initially would be blue. So for I in L1, so L1 has these three elements, blue, green, and red. And initially I's value would be blue. So I'll come inside this list and I'll print out blue. And now it's incremented and I'll go to the next element in the sequence, which is green. So I will have green inside it. I'll come in and I'll print out green. And then I'll go ahead to the final element inside the list, which is red. So again, I'll come inside and I'll print out red. So this is how the for loop works. Now we can actually create nested for loop. So that would mean a for loop inside a for loop. So for this, let me create two lists and two separate for loops. So I'll create, let's say, color, and I'll assign some values. So the values are green, yellow, and pink. And then I'll also add another list, and then I'll name the list to be equal to item. And I'll add a bunch of items to it. So let's say the first item is chair, the second item is book, and the third item is phone. Now I'll start a for loop. So for I in color, I'll add another for loop over here. So for J in item, I will print out I, J. And this is what we have. So let's understand this. So we'll start with the outer for loop, which goes through this list over here, which is color. So for I in color, so initially I's value would be green. Now when the I's value is green, we'll come inside the for loop and we'll start the inner loop for J in item. So initially J's value is chair. So I'll print out green chair. Now again, I'll go back and increment the value of J. So then we have book inside J. So I'll print out green book. Then again, J's value is incremented. It becomes phone. I'll print out green phone, right? So now the inner loop is also done. I'll go back to the outer loop and then I'll increment green to yellow. So now i's value is yellow. So again, I'll come inside the loop and then I'll print out yellow chair, yellow book and yellow phone. Again, I'll go back to the outer loop and then the value of I is pink. Then I'll come inside and then I'll print pink chair, pink book and pink phone. So this is how you can work with nested loops. So going ahead, we'll work with operators in Python. So we've got arithmetic operators, relational operators and logical operators. So let's start off with arithmetic operators. I'll head on to Jupyter Notebook over here, and arithmetic operators are basically the normal mathematical operations which you do. So that would be addition, subtraction, and then you've got division, and then you've got multiplication. So these are the different symbols which you'll be using to perform these operations. So we'll start off with addition. So let me just add in a comment. So to add in a comment, you will use this hash and then you'll type in whatever you want to add. So comments are basically statements which are not executed by the Python interpreter. And these are only to help the coder or the learner. Right. So I'll execute this cell over here. So I'll have one variable and I'll store 10 inside this, and I'll have another variable B. I'll store 20 inside this. I'll click on run. All right. So I'll start with addition operation. So I'll just type in A plus B and you get the value of 30. Well, this is quite simple. So this is the basic addition operation which you've been doing since your kindergarten, right? And also we'll be doing some similar operations. And then I'll go ahead and perform A minus B. So what do you think is the answer? Well, it's minus 10, because when you subtract 20 from 10, you'll get a value of minus 10. Now let's also multiply these two numbers. So I'll just type in A cross B. So that would be 10 into 20, which will give you 200. And then finally, I'll just type in A divided by B. So you'll get a value of 0.5. So 10 by 20 gives you a value of 0.5. So these were the basic arithmetic operations. Now we'll go ahead and work with some relational operators. So I'll just type in relational operators over here. So again, I'm putting down a comment. So relational operators. And relational operators basically help you to understand the relation between two variables. Now, what do I mean when I say it helps us to understand the relationship between two variables? So let's say when you have two variables, the value in one variable could either be greater than the value in the second variable, or it could be less than the value in the second variable, or it could be equal, or there might be no relation at all between these two variables. So this is where we'll have relational operators to find out what is the exact relation between two operands. Right. So again, I'll just type in A equals 10 and B equals 20 over here. I'll click on run. Right. So I'll start with the less than operator. So I'll type in A less than B. So over here, I'm just checking if the value of A is actually less than the value of B. So we get a value of true. This means that 10 is actually less than 20. Now let me check if A is greater than B. Now we get a false value because 10 is not greater than 20. Now I have the double equal to operator. So with the help of the double equal to operator, we check if both of these values are equal to each other. Again, we get a false value because 10 is not equal to 20. Now there is the not equal to operator. So A is not equal to B. So A, I'll give in this exclamation mark, and then I'll give in this equal to symbol, and then I'll give the second operand, which is B. So we see that A is obviously not equal to B, or in other terms, 10 is not equal to 20. So these were some basic relational operators. And then we'll go ahead and work with the logical operators. So I'll type in logical operators over here. So the two basic logical operators are AND, OR. And this is how you represent the AND operator, and this is how you represent the OR operator. Now we'll actually start with the AND operator. Now, AND operator is used to check the condition or the logic between two variables. And this is how the AND operator works. So if both of the operands are true, only then the final result will evaluate to true. And if either of the operands is false or both of the operands is false, then the final result will be false. So I'll just create two variables over here, and this time I'll be storing the value true inside A, and I'll be storing false inside B. So I'll just execute this over here. All right. So now I'll type in A and B. So we are basically checking true and false. So what do you think will be the result? We get a false value because we need two trues. And only when we have two trues, that is when we'll get the true value. Now we'll check B and A. So when it comes to B and A, we are basically changing the position of these operands. That's it. So now it becomes false and true. And the answer is false. Now let me check A and A. So this will be true and true. So when you compare true and true, you get a true value. And finally, let me check B and B. You get a false value. So this is how the AND operator works. Now let's go ahead and work with the OR operator. So when it comes to the OR operator, if either of the operands is true or both of the operands are true, then you get a true value. And only when both of the operands are false, that is when you'll have a false value. So this time I'll type in A or B. This would mean true or false. And obviously we have a true value over here. Then I'll type in B or A. So this would mean false or true. And we obviously have a true value. Now let me go ahead and check A or A. So this would mean true or true. So when you have two trues, obviously it's a true value. And then finally, let me check B or B. And we have a false. So this is the only condition where you'll get a false value when it comes to OR. So now we'll head on to Python tokens. So a Python token is basically the smallest meaningful component in a program. And in a programming language, or basically in Python programming, we've got these 4 tokens. So we've got keywords, identifiers, literals, and operators. So we've already understood what exactly are operators. Now let's understand what are keywords, identifiers, and literals. So let's start off with keywords. So as it is stated over here, keywords are special reserved words. Now these special reserved words will give a meaningful information to the compiler or the interpreter. So as you see, you've got all of these keywords over here: if, or, not, with, is, class, def, and so on. So when you type in this keyword, the Python interpreter or the compiler will treat this as a special reserved word, and it knows that it performs a special function. Now another thing to keep in mind is you cannot have a variable name or a function name or a class name to be a keyword, because this will cause an error. So as I've already told you, keywords are special reserved words, and obviously you can't use these special reserved words as the names of variables. So let me just go to Jupyter Notebook and show you some of these keywords. So I'll just type in if over here. So as you see, this has been highlighted in green. So in Jupyter Notebook, all of the keywords are highlighted in green. I'll click on run. So as you see, there is invalid syntax because if tells the Python interpreter that there has to be something followed after if. Similarly, if I type in, let's say, true, true again is a keyword which is reserved, right? Now I'll follow it with def. So as you see over here, this would actually create a function, but then again, this has to be followed with a function name. So Python interpreter is treating this as a special keyword and it has to be followed with something else. So the next set of tokens are identifiers. So identifiers are names used for variables, functions, or objects. So as in real life, if you have to call someone, people have names, don't they? So let's say you have your best friend whose name is Lisa, right? So Lisa is actually her identifier. So Lisa is being identified by her name. So similarly, if we have to identify something in the programming world, we would have names associated with them. So obviously the data which you've got are variables, functions, and objects. And if you have to identify these variables, functions, and objects, then we have to give them some sort of name. And these are the rules which you'd have to follow when giving a name to these variables. So you cannot have any special characters in the name of the variable, right? So except underscore, you cannot have any other special characters. Now, it is also important to keep in mind that these identifiers are case sensitive. So let's say if you given the name as Lisa where L is capital, and also then you have another identifier where L is small. So both of these would be different. Now similarly, you've got another rule over here. So the name of a variable, function, or an object, it cannot start with a digit. It can only start with a character or an underscore. So let's just check some of these rules in Jupyter Notebook. So let me create a variable with the name, let's say, I'll give it Lisa where L is capital, and I will store I am Lisa, Now I will have another variable with the name Lisa where L is not capital, and I'll store, let's say I am L. Now let me just print Lisa over here where L is capital, so I get the first one. Now I'll print Lisa over here where L is small, so I get the second one. So as you see, Python interpreter treats both of these variables as different because these variables are case sensitive. So we are done with identifiers. Now we'll go ahead to Python literals. So Python literals are extremely easy. So they are nothing but constants in Python. So they are constants which do not change. So basically you have numeric literals, you've got string literals, boolean literals, and so on. So whatever values are stored in the variables, those values are nothing but literals. Now let's say if you have a variable with the name A1 and you store a value Sparta inside this. So over here A1 would be the variable and you are storing a string literal inside this, and that string literal is Sparta. Similarly, now what I'll do is the variable name is A, but I'll be storing a numeric literal inside us, and the value of the numeric literal is 123. After this, I'll again give in a variable with the name A1 and I'll store a boolean literal. So the value of boolean literal would be true, right? So as you see over here, literals are nothing but constants and these are values which go inside variables. Now let's head on to Python strings. So Python strings are the most widely used data types when it comes to Python. And as I've already told you, strings are basically sequence of characters which are enclosed within single quotes, double quotes, or triple quotes. And triple quotes are used to denote multi-line strings. So as you see this example over here, I am going to France tomorrow. So you have triple quotes around the string because this is present in multiple lines. So hello world is present in single quotes. This is a string. This is Sparta is present in double quotes. And again, this is a string. But when it comes to I am going to France tomorrow, this is a multi-line string. So that's the basic premise for strings. So now let's go to Jupyter Notebook and work with these strings. Alright, so I'll create a new variable over here and I'll store a string inside this. So I'll put in the string Joey doesn't share pizza. I'll click on run. Alright, so obviously no one likes to share their pizza, do we? Right? So now let's go ahead and work with the string. So let's say I'd want to extract the first character, which is J, from this entire string. Now when it comes to Python, the indexing starts from 0. So J is basically present at index number 0. So if I want to extract J, I'll type in A1, I'll put in square braces, and then I'll type in 0. And I have successfully extracted the first letter. And similarly, if I want to extract the last character from this entire string, so for that, you'd have to put in -1. And when I click on run, you get the value A. So this is how you extract the last character from the entire string. Now let's say I want to extract a sequence of characters. So I'd want to extract this entire word, which is doesn't. So 0, 1, 2, 3, 4, 5. So the index starts at 5 and it will go on to 6, 7, 8, 9, 10, 11, and 12. So let me type in 12 over here. I'll click on run, right? Now over here I've given 12 because when it comes to the second term over here, it is exclusive. So 5 is inclusive, 12 is exclusive. So 0, 1, 2, 3, 4, 5. D is present at index number 5. Then 6, 7, 8, 9, 10, and 11. So T is present at index number 11. But if you only given 11 over here, then you'll get dozen, right? So what you have to keep in mind is when it comes to the second indexing term, it is exclusive. So that is why you'd have to go in till 12 and you'll get the entire word, which is doesn't. Now let's see how can we check the length of a string. So to check the length of a string, we have this length function. So inside len, I'll just pass in this variable, which is a1. And we see that the length of the string is 24 characters. Now when you say 24, so this would include all of the spaces and all of the apostrophes and full stops and all of those characters as well. All right. Now let's go ahead and work with some of the inbuilt functions of strings. So if I want to convert all of these characters into uppercase, so I'll just have to type in A1 and then I have this function upper. So I'll click on run. right? So I have successfly converted all of these characters to capital. Now similarly, if I want to change all of these to small case, so I'll type in A1 dot lower. So everything is turned to lowercase. Now similarly, if I want title case, so I'll type in A1 dot title. Right, so I have successfully changed all of these words to title case. So J is capital, D is capital. So over here, since apostrophe is taken as another character, that is why T is also given capital. And then we have S as capital and P as capital. Right, so these were some basic functions when it came to strings. So now we'll head on to the flow control statements. And in flow control statements, we'll start with the if statement. So in real world, you will come across a lot of situations where you'd have to make a decision on the basis of a condition. So let's say if this happens, then you'd have to perform a set of actions. Else, you'd have to perform a different set of actions. So let's take this example to understand this better. So let's say it's raining and you'd want to play football. So if it's raining, then you can't do anything and you just have to sit inside. Else, so if it is actually not raining, then you can go out and play football. So these are some of the real world situations which can actually be represented in programming with the help of if-else statement. So let's go to Jupyter Notebook and work with if-else. So here I'll create two variables. So I'll give in the value of 10 to A and I'll give in the value of 20 to B. And then let me check if the value of B is actually greater than the value of A. So if B is greater than A, then I want to print out B is greater than A. So since this condition has been evaluated to true, that is 20 is greater than 10, and since this is true, this statement has been executed. So we get B is greater than A. Now let me actually flip it. So I want to check if A is greater than B, and if this evaluates to true, I want to print out A is greater than B. So we don't get any result, and that is because this condition has been evaluated to false. And since this condition has been evaluated to false, this statement has been skipped. So this is where else clause comes in. So let me use else over here. Now I'll type in if A is greater than B, then I'd want to print out A is greater than B. Else I'd want to print out B is greater than A. Right? So here the first condition evaluates to false, and that is why it is kept. And then we given the else clause and this condition is printed, B is greater than A. Now let's say if we have multiple conditions. So if we have three numbers and we want to check which is the greatest out of those three numbers. So this is where we would need if, else. So let me actually assign the values again. So I'll assign 10 to A, 20 to B, and I'll also assign 30 to C. So now I'd want to check if A is greater than B and A is greater than C. So I'll type in if A is greater than B and A is greater than C. And if this evaluates to true, I want to print out A is the greatest, and this evaluates to false, then I'll type in LF, which stands for else if. So I'll give in the next set of conditions over here. So I'll type in B is greater than A and B is greater than C. And here I want to print out B is the greatest. So B is the greatest. And again, if this evaluates to false, I'll finally put in else and I want to print out C is the greatest. So here the final result is C is the greatest. Now let's understand this whole thing properly. So first we come to the if statement and then we check if A is greater than B and A is greater than C. That is 10 greater than 20 and 10 greater than 30. So both of these are false, and false would evaluate to false, and that is why we'll skip this statement over here. Then we'll come to else if, and we are checking if B is greater than A. So 20 is greater than 10, which is true. Then we'll check is 20 greater than 30. which is actually false. So true and false will evaluate to false, and again this is skipped. And finally we'll come to else and we'll print out C is the greatest. So this is how we can work with if else. Now let's use the if statement with a tuple. So let me create a tuple over here. So tup1, and let me give some values. A, B, and C. So I have created this tuple. Now after this, I want to check if the element A is present in this tuple. So if A and tup1, then I'd want to print out A is present. Alright, so since this condition is evaluated to true, that is, the element A is actually present in this tuple, and that is why we print this out. Now let me just check if the character S is present in this, and if it is present, I want to print out S is present. So this condition evaluates to false and nothing is printed out. Now similarly, let me go ahead and work with if and list. So if with list, and then I'll go ahead and create a list. So L1, and then I'll give it a bunch of values inside this. So 10, 20, 30, 40, and 50. Now I want to check if the first element in this list is actually 10. And if the value is equal to 10, then I want to change it to 100. So if L1 of index 0 is actually equal to 10, then I'd want to change this to 100, and then I'll finally print out this list. Right, so initially the first element in this list was 10. With the help of the if statement, I've changed it to 100. Now similarly, let me go ahead and work with if and dictionary. Dictionary with if. I'll create a dictionary, D1, and then I'll give it a bunch of key value pairs over here. So I'll type in the name of the fruit, which is mango, and then I'll assign the value, which is 10. And then the next fruit would be apple. And then the cost would be 20. And then the final fruit would be banana. And then the cost would be 30. Alright. So now I want to check if the value of mango is 10, and if it is equal to 10, then I'd want to add 100 more to this value. So if D1 of mango is actually equal to 10, then I'd want to add 10 more to this. So D1 of mango would be equal to D1 of mango plus 100, and then I'll print out D1 over here. Right, so initially the cost of mango was 10, then using the if statement I have incremented the value to 110. Right guys, so this is how we can work with the if statement.
So the next thing that we will discussing about is call by value and reference. So to be honest, Python doesn't have any call by value or call by reference. Basically Python utilizes a system and which is referred to be a call by object reference. So suppose in that event, you are passing the value in the form of integer, tuples, or strings. So we know that these are immutable objects, right? So the value will not be changed if you are passing these values to the function. So this can be likely referred as a call by value. So here you can see that I'm already having a function whose name is tech, and inside that I am passing a string. Okay, and then string is GL, right? But inside this function, I'm having a string great learning. So when you will print this, so as I told you, strings are immutable, so you can't change or update the value. So here inside this function, I will be getting the value as great learning. And here I've given the string as in GL, and if I'm printing outside the function here, so I will be getting the value of GL. So this is nothing but a call by value, or you can say that it can be referred to the call by value because I'm calling through a string, and then I may call through the integer or through tuples also. Let's see in the practical example. So let's start with the coding. So I will write DEF, which is a reserved word, and then I will give the function name, let's say a tech. And inside this, I will pass a string. So I've written a string here. So this is an argument. And inside this function, I will write, let's suppose, first let me write here a string. And here I will write, welcome to great learning. I can write, welcome to great learning. And inside this I will write print. So what I will do, I will write here inside, and then I will write string. So I'm just writing inside here just to get more clarity, that because this thing will be inside the function. Now outside the function, what I will do, I will write the same variable, or you can say the same argument that I'm passing into this function, and here I will assign the value as GL. And now what I will do, so I will print this function. So I will be printing like print, and then I will write outside. And after that I will write a string. And as we know that if you want to print any function, then you have to call it, right? So I will call the function also. So I will call the function, and I will write here attack and a string. And if I'm executing it, you can see that in outside I'm getting the value as GL, right? Where inside I'm getting welcome to great learning. So as we know that strings, integers as well as tuples, these are immutable, right? So you can't update their values. So here you can see that already inside the function I'm having a string value as welcome to great learning. So inside this function it will print welcome to great learning, whereas outside I've again write the same variable as GL, so outside it will print GL. So this was the basic idea about the call by value. So we can refer actually string and then tuple and integers as call by value. Now coming to the call by reference, mutable objects can be considered as call by reference, because so whenever you can see that there is any value change inside the function, you can see the reflection outside the function. So now let's understand the logic of set. So what I've done here, I've created a set here, right? And after that I've created a function. So here inside this function I have created a add method, right? So add will insert the value in a set, and if you are printing it, you will see that whatever the set, final set I'm getting inside a method, the same set will be I'm getting outside the method. So here I'm writing outside this, and if you want to print function, then you have to call it, right? So that's why I'm calling it here function, and again I want to print outside, so I've written here print method. Now let's see this set example in coding. What I will do first, I will write here set1, and inside this set1 I will give some values. Let's suppose 23, 45, 69, and then 78. And after this I'll create a function. Let me create a function. I will write def, and then I will give the function name attack, and inside that I will write set, and then I will use the set method, that is set.add, and let me insert the value. I will insert here, let's suppose 56, and inside this function I will write print, and I will write inside. So let me put into inverted comma this, and then after that I will write set. Okay, so if I print everything inside the function, then I have to call the function, right? So I will call the function attack, and then I will write here set1, and now I want to print outside the function, so I will write once again print, and here I will write outside, and I will write here set1. So you will see that in output we are getting the same thing. So whatever the value, even though you updated inside the function, it will be reflected outside the function also. So here I've created that set, and after that I am creating a method inside this function and updating it. So the updation will be done inside the function as well as the outside the function. So this is the basic idea of call by reference that you can do from the mutable objects such as list or sets. So I've showed you the example of set.
So the installation of Anaconda is done, and we've understood what exactly is Anaconda Navigator and also Anaconda Prompt. Now, what is this Jupyter Notebook? So as it is stated over here, Jupyter Notebook is basically a browser-based interpreter that allows us to interactively work with Python. So this is just a screenshot. So let's head on to actual Jupyter Notebook and start working with it. So we have to create a new notebook first. So to create a new notebook, we have this new tab. I'll just click on this new, and I want to work with a new Python 3 file. So I'll click on Python 3. Now I will go ahead and give the notebook a name. So I will name this as, let's say, let me keep P to be capital over here. So I will name this as Python for non-programmers. So I have successfully given this a name. Now let's look at all of these tabs over here. So let me click on File. So if you want to create another new notebook, click on this, click on Python 3. So you have a new notebook over here. So similarly, let's say if I have to open a new file which is present in my system, you click on open, then you can save this file, rename this file, you can save in checkpoint. If you want to save this, so you have all of these options over here. So normally we save these Jupyter notebooks as .ipynb files. So I'll just click on this, and as you see over here, the download has started. Now let me go to the edit. So this part, what you see, this is actually known as a cell. So with the help of this edit tab, you can cut cell, copy, paste, delete, split, and merge. So you've got all of these different operations over here. Then you got the view tab, right? So you've got these toggle options. You can toggle the header, you can toggle the toolbar. And then you've got inserts. You can either insert a cell above it, or you can either insert a cell below this, right? It's as simple as that, right? So if you want to run a cell, then you have all of these options. And then we've got something known as a kernel. So you can consider the kernel to be basically the executor of the program. So you write your code over here, but the question is, how will the code be executed? So this is where the kernel comes in. This is what will execute your program, right? So these are the different operations which you've got over here, right? So also if you need any help, then you got all of these. Now, let's say instead of clicking on all of these tabs, if you wanted to work with shortcuts, so just click on this keyboard shortcuts and you got all of these different keyboard shortcuts, right? So just look at these keyboard shortcuts and you can use them. So let's go ahead and write our first Python program. Now, let's say I like the movie 300 very much and I absolutely love this dialogue. This is Sparta. So I'll just type in that. So I'll type in print and then I'll type in this is Sparta. Now I'll click on run. So as you see, we have successfully executed our first line of Python code. So guys, you're on your way to hacking NASA systems. Isn't it just amazing, right? So you've just taken the first step to learn Python. Now there's a lot to learn. So we'll be learning all of them in a step-by-step approach. So get your seatbelts ready.
So now we are going to do the Python practice codes, and I will explain you how this data structure works in Python. So let's start with list. How to start with list, right? List is the data structure again. Now, if I write demo, this variable called is demo, and how can you do that? Now you have to use a square bracket. Can you see this is the, I cannot make it more big than this. So can you see this is the square bracket? Under that we have written Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, right? What is your question? How to convert a list into a string? How can you convert your list into string, right? Okay, right. So in this case, if I just execute this, then if I just write type of the demo, what is the type of the demo? The type of the demo is list. So you can easily understand you have actually, yes. So you can easily understand you have easily done this type, implement or initialize a list, right? Now, what we are going to do? We are going to convert this list to string. How to do that? These are the very basic code snippets you need to start with if you actually need to crack any interview, right? So you can see const string equals to dot join function, right? So const string is basically your new string name, right? Right. So you have written const string equals to, then you have written dot join, and you have given what? Your list, right? If you now print it, right, you can see you have actually get this const string and you get all the data you had in list. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. And if you just trying to check the const string particular, so basically why I have given con underscore string, so convert it to string, right? So you can see the type of converted to string is string. So you have actually successfully converted your list to string. So basically how to convert a tuple, but before that you have to understand what is tuple. So if you just write tuple demo, right? Here is the main magic you need to understand. For list you have to use a square bracket. For tuple you have to use a round bracket. And under that if you can write sun and you can write month, right? Now if I just write type of tuple demo, you will get what type it is. It is the tuple type. Now I will say what is tuple. Tuple is one of the 4th built-in data types in Python, right? This is the data types for Python again. So it is used to store collection of data, and we have that is list, set, and dictionary, right? And the main thing about tuple is ordered and unchangeable. After you initialize tuple, you cannot change it. So this is the basic difference between list, set, and tuple. You can change list, you can change set, but you cannot change tuple, right? So you have to understand what is tuple, right? Yes. So you can understand here that tuple is nothing but your unchangeable list. So that's why we use tuple. Now I just want to change my list into tuple. What you need to do? You just need to write tuple, and then you can actually easily change this demo to contuple, right? To convert it to tuple. What I have written after that, type. Right. So you can see this is tuple, right? Yes. So we have talked about list. We have talked about tuple. Now we will talk about set. So what is set, right? So in order to actually have set, let me tell you one thing. Set has all the unique number. Suppose you have something called demo set, and you are going to write in the curly brackets. Set always we write in the curly bracket. You have written 1, 1, 2, 3, 4, 5. Let me show you how it's going to react on that. Now, if I just write demo set, what I will get? I will get 1, 2, 3, 4, 5. Can you see what are the repeated number we had? We had 1 for twice, we had 5 for twice. That is already what? That is eliminated. So for the set, one thing you have to remind in your mind that set is something where you cannot have duplicate value. All the value you will have the unique value, right? Now, to change in a list to set, again you have to write set, and then you have to pass your list, right? After doing that, can you see the type of converting to set is set, right? Now we are going to do a little bit a little bit difficult one, not the difficult one, but still there is a question: how can you count the occurrence of a particular element in a list? So as we have talked about how to understand the occurrence, right? So suppose, let me show you one particular example. Suppose you have a demo, right? So you have demo equals to Monday, again Monday, then you have Tuesday, then Wednesday, right? Then again Wednesday, and so on, right? Then you have Thursday, right? And so on, dot, 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 right? So let me make it, let me make it commented one, right? So suppose you have something like that. Now, what we need to do, we said, I just want to have the count. So how many times you have Monday in your list called demo? So before that, let me just print demo here, right? What we have here, we have Sunday, we have Monday thrice. No, 4 times we have Monday here. 1, 2, 3, 4. Now, if you want to check what are how many times we have Monday in the list, right? That time you have to use a function called dot count function, and here you have to mention what you want to check in this particular list to be counted, right? Okay, now you can see here it's 4 times. Can you see? Yes. So we have 1, 2, 3, 4. So we have total 4 times Monday in this particular list. Now if I write Tuesday, how many times we have Tuesday, right? We have 1 time Tuesday, right? Can you see? So this is how you can use the particular count function in this particular, checking that for a particular, for a particular variable, for a particular thing, if you want to check how many times it has occurred to your list, Now we will talk about concatenate. What is concat? Concat is adding, right? You have different variable or you have different string. Now you want to concat them, right? How to do that? Suppose you have three variables. One variable is A, one variable is B, one variable is C. A equals to welcome, B equals to 2, C equals to you have great learning. Now you want to make a full sentence, welcome to great learning. How to do that? In order to concatenate something in Python, the most easiest path to do that, right? Okay, so in this case, you can write print A plus B plus C. Can you see what you will get? Okay. So sorry, I did not. Yes. Can you see what we get? We get welcome to great learning. So this is how we can do this particular concatenation.
So now let's see what is leap year. So a leap year is a year which is having 366 days, whereas a normal year has 365 days. So if I'm having a normal year, so normal year will be having 365 days, whereas my leap year will have 366 days. So we are having 1 day extra in my leap year. So what will happen here? In February, we are having 28 days in a normal year. But here in leap year, we will be having 29 days. And also leap year comes after 4 years. So here leap year has 366 days, whereas normal year has having 365 days, and it comes after every 4 years. And we have already discussed this also, that February is having 29 days in leap year. So these are the examples. You can see 1988, 1996, 2000. These are the leap years. So now let's understand the logic for leap year. So many of us think that if a year is divisible by 4, then it's a leap year, but this is wrong. Now let's understand the logic for leap year. Let's suppose that this is a year 2004 and I want to check this whether this is a leap year or not. So first I will check it whether it's divisible by 4 or not, and along with that it should not be divisible by 100 also. So I will take two cases here. Let's suppose that if I'm having a year which is not a century year. So let me give you idea about century. So in 1 century we are having 100 years. So if a year is a multiple of 100, then it's a century year. So let's suppose that 2000, here you can see that it's a multiple of 100, then it's a century year. 2100, this is also a century year. 2200, this is also a century year. So first we will build a logic for a non-century year. So for that the number must be divisible by 4 and it should not be divisible by 100. So what I will write here, let's suppose this is my 2004. So if I want to check this whether this is leap year or not, so it must be divisible by 4. So if I am dividing it with 4, you can see that it is divisible by 4, right? Now since this is not a century year, right, so it shouldn't be divisible by 100. So if I'm dividing it by 100, so it will be not divisible. I will be getting a remainder as 4. So this is a logic that I have built for a year which is not a century year. So the logic is simple. It must be divisible by 4 and it must not be divisible by 100. Now what will happen if, let's suppose that if I'm having a century year like 2100 or 2200 or 2300, if you want to check whether it's a leap year or not, then the logic is simple. It must be divisible by 400. So let's suppose if I want to check whether 2000 is a leap year or not, so I will divide it by 400. So you can clearly see that 2000 is divisible by 400, right? So if you are going with the logic of that a leap year is divisible only by 4, then you will be wrong. Let's take an example of 2100. So if you divide here 2100 with 4, so here you can see that that 2100 is divisible by 4, but it's not a leap year. So that's why we will use this logic, because 2100 is a century year, so we will divide it by 400 and then we will see. So if we divide 2100 with 400, then it's not divisible, hence this is not a leap year. So this is a simple logic that I have built for the leap year. So what I will do here, after creating these two logic, So now what I will do now, I will create if and else statement, and inside if statement I will put this logic. So when I will be having a leap year, either this condition satisfy or this condition satisfy. So I will put or. And after creating if, I will write else statement, and if this condition is not satisfying, then it is not a leap year. It's simple. So let's see the coding example for it. So I will be using here Jupyter Notebook. So I'll go on here new, and then I will click on Python 3. And let me give here the file name as leap year. So what I will do now, first I want to take the input from the user. So I will create a variable a, and then I will write here int, and then I will write here input. I will write here enter a number. So we know that in Python, if you want to take a user input, then you can write this method. So after writing this, I will create if and else statement. So I'll write here if, and I will give here the logic. So instead of a, let me write here year. You can write anything here, but year will be more easier to understand. So I will write here if year is divisible by 4, and year is not divisible by 100. So this is my first condition that I will be using for a year which is not a century year. And then I will write here or, and then I will write here simple year modulus 400 is equal to 0. And then I will write inside the if statement print it's a leap year. So if this condition is satisfying, then it's a leap year, and if condition doesn't satisfy, then it's not. So I will create another condition here else. I'll write print it's not a leap year. So let me execute this. So before executing, let me write here equal to, and now if I'm executing it, then it's asking enter a number. So let's take a number 2100 first. We know that 2100 is not a leap year. So if I'm writing here 2100, you can see that I'm getting it's not a leap year. So let me check for other years also. So I will click here on run, and it's asking enter a number. So I will give here 2000, and as we know that 2000 is a leap year, so let me execute it, and here you can see that it's a leap year. So this is the basic idea for a leap year program. So now let's take a quick recap for this course. So we have started this course by understanding what Python is. We have also seen the applications of Python along with the Jupyter Notebook, that it's a web application. Moving ahead, we have seen variables, data types, operators, and then we have also seen the tokens along with the conditional statement. And at last, we have seen the logic for the leap year program, as well as we have also seen the coding implementation for it. So now let's see what is prime number. So a prime number is a number which is divisible by 1 and the number itself. Let's take an example of 5. So let's suppose this is a 5. And as I told you in the formal definition that a number is divisible by 1 and the number itself will be a prime number. So if you divide 5 with 1, it is divisible, right? If you divide with 2, will it be divisible? No. With 3? No. With 4? You can't divide 5 with 4. And if you're dividing with 5, yeah, it will be divisible. So here you can see in the definition that a prime number is divisible by 1 and the number itself. So 5 is divisible by 1 and the number itself. So this is a prime number. So this is an example of 5. Let's take a 3. If you want to check whether 3 is a prime number or not. So it is divisible by 1. Yes. It is divisible by 2. No. It is divisible by 3. Yes. So again, it is a prime number. Now 0 and 1 are not prime numbers, as we know that 0 and 1 are not prime numbers, right? And then 2 is the only even prime number. If you take the example of 2, then it is divisible by 1 and it is divisible by 2, right? So 2 is the only even prime number. So let's take one more example. Let's take the example of 13. If you want to check whether 13 is a prime number or not, so first, if you divide it by 1, it is divisible with 2, 3, 4, 5, 6, 7. So if you divide with these number 2, 3, 4, 5, 6, 7. Is 13 is divisible? No, it's not divisible. Now 8, 9, 10, 11, 12 and 13. So is 13 divisible by 8? No. Similarly for 9, it's not divisible. Similarly for 10, 11, 12, it's not divisible. So here 13 is divisible by 1 and 13 itself. So this was the example for prime number. Now let's see the logic for prime number and its coding implementation. So the next program that we are having is prime number. So let's understand what is prime number. So the prime number means the number which is divisible by 1 and the number itself. Let's take an example of, let's say 15. If you want to check 15, so 15 is a divisible by 3, right? So it can't be prime. And if I'm taking the example of 5, so 5 is divisible by 1 and the number itself 5, right? So it's a prime number. So now let's understand the logic of prime number. Let's say if you want to find out whether 13 is prime or not, right? So as I told you that prime number is a number which is divisible by the number itself and 1. So 13 is divisible by 1 and 13 itself, right? But we have to check that whether it's divisible by 2, 3, 4, 5, 6, 7, 8 and so on up to 12, right? And if it is divisible by any number from 2 to 12, then it's not a prime. So this is a logic. So what we can do here, I will write a for loop. So I will write for I in range. So I will start the range from 2 and up to the number itself, right? Because the prime number concept was simple, that it must be divisible by 1 and the number itself. So if I am writing here number, then it will not include this number, right? So it will start from 2 to number minus 1, right? So this was the logic. Now here you can see that this is the logic, right? So here if you can see that if I'm writing, let's suppose x is equal to 5 and this is the remainder operator, right? So whatever the value of I am getting from this range, so if I see any number that is in between the range and if it is divisible, then it's definitely not a prime number, or else it's a prime number. Now let's see in the coding part. Yeah, so what I will do here, I will just take a number. Let's suppose I will write here number is equal to, let's say 19, and I want to check whether it's a prime or not. So what I will do, I will write here for I in range, and then I will write in range from 2 to this number. And inside that I will give a simple logic. If this number, and then I will write modulus operator here. So I will write here, and if it is equal to 0, that means if it is divisible, then I will print it's not a prime. And after that, if the condition is not satisfying, then I will write else. I will write print it's prime. So I can write else here, but I will not write. Why? Suppose if there is any number that is in between the range and we got to know that it is divisible, right? So we got to know it's not a prime. Then what's the point of repeating the loop? So that's why I will write else condition here, and then I'll write it, and let me write inverted comma here, and if I'm executing it, then you can see that number 19 is a prime. Now if I'm checking another number, let's suppose that I'm checking 23, then you can see that it's again a prime number. So this was all about the basic concepts of prime number. What is GCD? So now if I'm talking about GCD, so it stands for greatest common divisor, and even we say it SCF. So SCF is nothing but highest common factor. So how to calculate SCF of two numbers? So basically if you want to calculate the SCF of two numbers, then it is the highest number, or you can say that it is the largest number that divides both the two numbers. So let's take an example to understand in a better way. Here I am having the example of 4 and 6. So these are the two numbers. So let me find the factors. So when I'm talking about factor, that means 4 is divisible by which all numbers. So we know that it is divisible by 2, right? So I can write here 2 into 2. And coming to 6, I can write it 2 into 3. So what is the common factor here? So the common factor is here 2, right? And what is SCF? SCF is nothing but the highest common factor. So here if you see, then we are having the highest common factor here 2.
So the SCF of 4 and 6 is 2 here. Now let's take another scenario, 12 and 28. So which all numbers can divide this 12? We know that 2 can divide 12 and then even 4, right? So I can just write here 2 into 2 into 3, and for 28 I can write here 2 into 2 into 7, right? Now I can also write 12 and 28 as 4 into 3 and 28 as 4 into 7. So now, as I already told you, that SCF is nothing but highest common factor. So here you can see that highest common factor we are having 4, right? So SCF of 12 and 28 is 4. And you can also split like this way, 2 into 2 and 2 into 2 is nothing but 4. So this is the basic idea about SCF. Now you might have a question. Let's take an example of 2 and 3. So what will be SCF for 2 into 3? I can just write here 2 into 1 and 3 into 1. So SCF of 2 into 3 will be 1, right? Because 1 will be the always common factor. So this is the way to calculate GCD or SCF of two numbers. Now, if we want to calculate the SCF in programming, we can't do in this way, right? So there must be an approach. So let's see the pseudocode. How can we work in the programming? So now let's understand the logic of SCF. So let me draw a number line. So let's suppose that this is my number line. This is 1, 2, 3, and so on. So I will take two numbers here, x and y. So let's suppose x is equal to 12 and y is equal to 28. So this will be your x as 12 and y will be here as 28. Now, if I want to calculate the SCF, then how can I calculate it in programming? So what can I do here? I will just develop a logic. So for the Python programming, I can take the user input by using the input method, right? Input enter a number and I can take the value from the user. Now after taking the two values x and y, what I will do here? So now we have to build the logic. So for building the logic, what can I do? I will using a for loop here. So I will just write here for I in range. Now range will start from 1, right? So this is my number line, so it will start from 1. So after this I have to write the range maximum value. So if I want to find the common factor between two numbers, so for that I need the minimum value, right? So let's suppose x is equal to 12 and y is equal to 28. So which is having the minimum value? 12. Why can't I take 28 here? Because let's suppose if you are taking the value 28, so you can't divide 12 by 28, right? And we have to also find the common factor. So here I will just write here minimum, because minimum value I have to take. And when you compare 12 and 28, your minimum value is 12, so 12 will be coming here. Now I will just write here minimum plus 1. Now you might have a question, why I'm writing here minimum plus 1. So let's suppose if I'm writing here minimum, so minimum value is 12, right? So we know that this last value will be excluded. So it will take the value from 1 to 11. So here when I'm writing here minimum plus 1, so minimum value is 12, 12 plus 1 will be 13. So from 1 to 13, it will take the value from 1 to 12, right? So this will be the value for I. So now in this for loop, I have to put the two conditions. So the condition is very clear, right? It should be the common factor. So what I have to do, so let's suppose this is my number 12. So I have to check it whether 12 is a factor of 1 or not, 12 is a factor of 2 or not, 12 is a factor of 3 or not. So I have to check one by one. So I'll give the condition here, if x modulus of I is equal to 0, and the second condition I will also check for this 28 number. So this is my y. So I'll just check y modulus I is equal to 0. So now what will be I here? So we know that I will take the value 1, 2, 3, 4, 6 and so on. Up to 12 it will take, right? So x value is here 12. So first time it will take 1. And then it will cross check 12 modulus 1 is equal to 0. No, then it will take the value 12 modulus 2 is equal to 0. Yeah, this condition is satisfying. Then it will check for the y1. So y is 28, right? 28 modulus 2 is equal to also 0. So our SCF will be 2 for the first time. Now you might have a question, but we have to find the highest common factor, right? So as we know that this is a loop, so this SCF value will be updated, right? Once the iteration will continue, this SCF value will be updated. How? So here if you see I value will be 4. So we know that 12 is divisible by 4 as well as 28 is also divisible by 4. So this will be the SCF. And we know that the highest common factor for 12 and 28 will be 4. So this is the basic logic for the SCF of two numbers. So now let's see the practical implementation. So I will be using here Jupyter Notebook, and you can see that my Jupyter Notebook has opened. So I'll just click on new and Python 3 file. So this is my file, and I can change the name here also. So let me just change the name here. So I'll just write here the GCD simple name. And now what I will do here, first I have to take the input from the user. So I'll just write here n1 and integer input. So I'll just write here input, enter a number. So we know that when we are writing input enter a number, so it will return as the string value. That's why we have written integer there. So whatever the string value you will be getting, it will convert into the integer. So we have to take two values to calculate the GCD. So I will just once again write here n2 and integer input enter a number. Okay. Now I will give one simple condition. So I'll just write here if n1 is greater than n2. So I will just write here simply. So I'll just create a variable and let me give the variable name as minimum. So I want the minimum value to be used in the loop, right? When I'm using the for loop. So if n1 will be greater than n2, so the minimum value will be n2, right? Or I will give the condition else. In other cases, minimum is equal to n1. Now I will just use the simple logic. I will just write here for I in range, and we know that the range will start from 1, and I will just write here minimum plus 1, and inside this I will just give a condition. The first condition will be if n1 modulus of I is equal to 0 and n2 modulus of I is equal to 0. So I'll just write here SCF is equal to I. Simple. So now let me write here print, and I will just write here print function outside this loop, and inside this print function I will just write SCF of two numbers is, I'll just write here SCF. So let me execute this. So if I'm just clicking on this run, you can see that I am getting an error. Why? Because I have to use here colon, right? Now if I'm executing it, you can see that it's asking enter a number. So let's suppose that if I'm giving the value as 12, and in another case I will give the value as 28. So what happens here? Here my n1 is 12, n2 is 28, right? So here you can see that 12 is greater than 28. No, so this condition is not satisfying. So my minimum will be equal to n1, right? So minimum will be equal to 12 here. Now this minimum value will go into this range. So it will take the value minimum plus 1. So 12 plus 1, 13. So now I will contain the value from 1 to 13. That means it will show 12 values from 1 to 12. Now it will check the condition, right, from 1 to 12, which can be the factor of these two numbers. And as soon as we are getting the SCF, it will be updating, right? So we know that SCF of 12 and 28 is 4, right? So on execution, you can see that SCF of two numbers is 4. Now, instead of 12 or 28, let me take the example 2 and 3. So we know that the SCF will be 1 here. So on execution, you can see that the SCF of two numbers is 1. So this is the basic idea about GCD of two numbers.
Now we should understand how this game works in the introduction. Tic-tac-toe game is also known as X and O game. We have two different players. Either one can choose X or O. If player 1 chooses X, by default player 2 will be having O. If player 1 chooses O, by default player 2 will be having X. These are the only two combinations where the characters can be chosen. Apart from this, we also have a board or a grid that is in 3x3 format. That means 3 rows and 3 columns. So we also call this game as noughts and crosses. So when this person or a player is considered to be a winner, only when either of the characters X or O is being placed consecutively 3 places, either it might form a vertical consecutive place or a horizontal or a diagonal arrangement, that particular person or a player is known to be a winner. So this is basic rules which we have followed, which we have played in our childhood, and this is the game all about. First, let's understand in normal English language what are the different steps we have to follow. Nothing but a kind of algorithm. So let's quickly hop into the step 1. Designing the tic-tac-toe board. We have to design this particular board in order to place the characters inside. Right? The platform should be made ready. 3 cross 3 is the format, that is 3 rows and 3 columns. The numbering of the cells goes from left top corner. That is 1 starts from left top corner and the 9 ends at right bottom corner. So this is the format we follow. And in step 2, we have to store status of the board and every player's moves using data structure. Right? So status of the board might be either of 3 different status. One would be empty, second would be filled with X, third would be filled with O. What about players' moves? Every player move, either it will be X or O depending upon the choice made by that player at the starting of the game. If player 1 chooses X, then player 2 is obviously have to take O. If it is O at the end of the player 1, obviously it is X at the end of player 2. So we have to keep track of each player's move. In step 3, we should know what is the loop of the game. Every game has its own method of running, own method of execution. So until the player will win or the game will be drawn or the player will lose, we also have to execute the iterations every time. Every time we have to check every move that player makes, we have to check whether the status of this or the result of this game is in win or draw or in lost mode, right? So we have to loop the game in step 3. In step 4, we have to handle or players moves how the iteration goes, right? In every iterations or every player's move, we have to check whether the character chosen or the inputted character is X or O only. We should not allow any other characters. So the next condition is whether the grid or the number of the cell chosen by the player is ranging between 1 to 9. Either it should not be 0 or it should not be 10 also, right? So we have to check for that condition. The third condition which we have to check is whether the selected cell is filled or not. Sometimes there might be repetition of that particular cell where the player might choose by mistake. We have to create exception handling methods for all these. What if all this problem occurs, how the code will self-repair, right? In step 4, we have to form exception handling for all the 3 conditions listed. Step 5, we have to update the grid accordingly. Every iterations, every player move, we have to improve or update the grid, right? The grid update according to the player's move is the step 5. Step 6, we have to check the status of the game result. Every step we have to check whether the game is in win mode, lost mode or a draw mode, right? We write function only for win or draw here. Why? Because if it is not both, then it is obviously the player has lost the game, right? So losing would be by default. Either if it is not, he is not winning, nor the game is in draw mode, obviously he is losing the game. So in step before going to step 7, we have to also consider that we have 2 different conditions here. How do we declare the game is in win mode or in draw mode? Win mode has 8 different combination of the numbers or the grid numbers or the cell numbers where the person can win horizontally, diagonally and vertically. So we have to mention all these cell numbers and we have to make, if this particular character consecutively falls in this particular combination of numbers, we have to consider that number or that combination into a win mode. So anything apart from this, these 8 combination, it is a draw mode or a lost mode, right? So condition for draw. What might be a draw condition here? When all the 9 cell spaces are being filled, then that particular game is a draw game, right? So these are the 2 conditions we have to follow and check in step 6, right? In step 7, we have to exchange the player turn every successful iteration. After player 1, it has to be player 2. Again player 1 and player 2. So this should go on until the result has been declared, either win mode, draw mode, or a lost mode, right? The turns to be given in step 7. In step 8, we have to code for scoreboard. Scoreboard is very necessary. So in order to have a scoreboard, we have to get the names of the players, right? Player 1, what might be the name? We should give them an condition or a printf statement or a print statement where they can accept the input from the user, and we have to store that temporarily, their name, until this particular code is being completely executed, right? So we have to maintain the scoreboard. So we have to get the names of the players who they are playing with, right? So either player 1 name and player 2 name also. So that is step 8. Coming up to the step 9, we have to store information related to the game. What are the different information we have in the game to be stored? Which player chooses X or which player will be choosing O? Obviously, if you know one player's option, another player is by default, either it is X or O depending upon the player 1's choice. Player's turn. Who is playing first, who is playing second? And scoreboard updates. Every iterations, what are the different score that particular person has scored. How the scoreboard will update is only when that person wins. That's about it. We are not going in depth of maintaining the scoreboard. We are just having the scoreboard, how many games player 1 won and how many games player 2 won. So that's about it. So in step 10, we have to design scoreboard using dictionary in Python, right? So keys will be the name of the player and the values will be the score, that is win numbers. That's about it. So step 11 is having menu for choosing the symbol. First, when we start the game, we have to give options to the players where they can choose either X or O, right? So in step 12, we have to handle and assign players choice every iteration. So what is the move the player is taking, where the X is being placed, where the O is being placed. So this particular move should be taken into consideration, and we have to assign and handle player's choice. So coming up to the 13th step, we have to execute the match. We have to execute the code. Every time from starting to end, we have to make sure every player gets equal opportunities, and as soon as the game has been terminated, we have to close the program. So execution should be taken into consideration. So step 14, update the scoreboard accordingly. Every time we win the match, we have to update and we have to ask the user or the players whether you want to continue or you want to quit the game. So accordingly, the scoreboard gets updated. How many games they play, that many times this win number will be updated in the scoreboard. Let's quickly see how do we implement the steps which we learned in the previous videos into a coding format. Why wait? Let's quickly switch to the IDE where we can put up the codes and try to form tic-tac-toe game. So here I've already put up some code in order to make you people understand what are the different functions we need, what are the different elements we need in order to form this particular game, right? Starting from the first step here, I have written a function in order to create tic-tac-toe board, right? I'm using list with places reserved from 0 to 8 because it starts with 0 by default. Hence, there are totally 9 spaces, 9 boxes in the grid, that is 3 cross 3 grid. It is having 3 rows and 3 columns. So these particular curly braces will always let us to put up the values whatever the player or the user puts up while playing the game, right? So this is about the function which we create in order to form a board, the initial grid, right? So that is the function. And hopping up to the next one, we have a scoreboard. So I'm starting with the functions where we need a basic elements like grid, scoreboard, names of the players, etc. So initially the scoreboard will be 0 because no game has been played yet, right? So this is just the scoreboard which is having the heading scoreboard for tic-tac-toe and player names, and the score default will be 0 until at least one single game is played. So that is the function in order to print scoreboard for the tic-tac-toe game. Next, we have function to check which player won the game, right? So as I've told you, we have to check each and every iteration if any iteration might match with these particular 8 combinations. How does this 8 combination come? I'll explain you how it is, right? We have named the grid from left top corner starting from 1 to right bottom corner ending with 9, right? So we have to know 8 different combinations. How am I taking the combinations? I'll let you know. That is row 1, row 2, row 3, right? Again column 1, column 2, column 3. 3 plus 3 is 6. Two diagonals we have from left to right bottom corner, from right top corner to left bottom corner, right? So 3 plus 3 plus 2, right? We have three sets, because of having 3 rows and 3 columns, 3 elements we have in each set, and we have 8 different combination of those. So if any of the combination, either of the combination in these 8 sets will match, at least one it will match, then it is always considered the person who is matching this either with X or with 0 consecutively in these any of the one combination out of these, he or she is a winner. So this is a winner condition which we have to follow, right? So that is how it will check for these combination. Either of the one set is matching out of all these, it will try to convey, return back the value to the main program that player position, that is player 1, that is current player, is been uh, winning the game once, right, or twice, depending upon what is the loop of the game, whether the game is third game or fourth game. So it depends upon that, right? So here the current player might be player 1 or player 2 has won the game. If it is true, it will return true. If it is false, it will return false. No, none of the combination is being matched, then it is false always. So once it is false, let's check for the next function what it happens. So we have to see when the user is not a winner, at least next in each and every iteration, it has to try to see whether all the grids are being filled. Say, if all the grid or the boxes is being filled, then it is known to be a draw. It is not matching all the combination of the winning combination also. It is filled up with all the boxes. There is no other way. Then either player 1 is not the winner nor player 2 is not the winner. So nobody is the winner here. The match is in draw. The game is in draw. That is how we conclude. So we have to check 2 different conditions for each and every move the player makes. One, whether any of the person is a winner, or if the match is been draw. So we have to check for these conditions regularly. That means each and every move, each and every iteration. Hope this is clear. Fine. So next we have function for a single tic-tac-toe game. So every game which it goes, it has to go through with this function. So let's understand what is this function all about, right? So here we have to keep the track which position is occupied by X or which position is occupied by O, right? Player 1 will select X. Obviously, player 2 will have to work with O. And X is being put up in which place of the grid? 1, 2, 3 or 4. You have 9 different combination to put up, right? So we have to have this temporary updation databases where which position is taken by which character and which player. We have to keep all these in lane, right? So after this, we have looping, right? Looping, what happens in game loops, usually we have to have some conditions where the exceptions are handled. There is chance of making errors by knowingly or unknowingly by the user or the player, right? What are the different errors it will occur and how to handle? Why I have put up these things in exception block? Let me just explain you this, right? So here I have try block. So what I'm trying to check here is whether the player has given a proper input or not is the first main concern. So what are the different conditions you have here in order to satisfy, in order to clear, is the first condition whether the person is giving any alphabet except X or O. We have to check that first, because keyboard has so many numbers and the user can type anything intentionally or unintentionally, right? So we have to first check for the character is matching, either it should be X or it should be 0 or O, right? So first thing is that if that is the case, then we have to return an error message, wrong input, please try again later, or something. You can customize whatever you want to print and communicate to the user. Here I have given wrong input, try again. The next thing you have to understand is, here if you could see in if statement, I have a condition, move is greater than 1 or move is lesser than 9. That means the number which they choose in order to store their character, irrespectively it might be X or O, where they are storing that on the grid, right? So it should range between more than 1 and less than 9, right? So we have only 9 boxes in the grid. The person cannot give 10, 11, 12 or 13 as in position. When that happens, we have to throw up an error message to the user conveying, please choose the right number between 1 and 9 or 1 to 9, right? So that is how it goes. Next, we have to check for one more condition. First thing, I repeat, we have to check whether we are having a character which is mentioned, which is under the rules, that is X or O. Second, we have to check whether the grid or the box number is ranging between 1 to 9. Third thing which you have to check here, what I'm trying to check here is whether the place which is taken or given as an input, the box number, is being filled already or empty. We have to check that first. In case if that box number is being repeated again and again, it will land up to an error. So all these three conditions has to be inside exception block, because in order to self repair the code rather than ending up with a garbage value or sudden stop of the code, in order to avoid all these things, we have to have these conditions priorly in the exception block. So if this case happen, what would be the solution? If that happens, what would be the solution? So we have to think as a programmer what might be the constraints which will come up, right? So here as the third one, as I explained, whether the place is being occupied or not should be taken into consideration. If it is occupied, if the grid number or the box number given by the player or the user is matching, right? So then we have to give the place you have chosen is already filled, please try again, or anything you can put up in order to communicate, to convey to the user what you are doing is wrong, it has already been taken, please choose any other number. So these are the three things which have to keep in mind for every iteration of the game or every time you play the game, right? So apart from that, you have board status. I mean to say, scoreboard should be updated, right? So every time the board should be updated, where we have to have certain numbers that is going on and on. It started from 0 by default. If one particular iteration is complete, that means one particular complete game has been done, we have to at least choose who is the winner or who is the loser, right? Whether the game has been won or it is in draw mode, and we have to keep that status on. Then we have to update the positions of the player. The next thing, why we have to update position of the player? The reason is because if player 1 starts, next should be player 2, again 1, again 2, the iteration should go on. So we have to keep on updating the player's position from 1 to 1 2. That is how it goes. We are appending it, right? We are moving the number. So after that, we have to check for winner. As I told you, every time, every move, we have to check for the winner. So once you give up this, once you give this particular block function, when the when the player is being considered to be a winner, that means all the 8 different in the combinations which we have, either of the one will be successful out of this 8, then we have to consider that particular player as a winner. So that is how it goes, right? We have to check winner, player position we have to see, current player we have to see, and the player number, that is player number 1, player 1 has won the game, so we have to declare the player and send the number to the function, so in order to execute, right? So after that we have to check whether the game is a draw, right? As the function is written already, the same function will be called here. What is the draw condition? All the boxes in the grid to be filled. If it is filled and it is not matching any of the combination of the winners, the 8 combination, then the game is draw. So we consider the game is draw and we give that particular print statement out to the users to see. So after that, as I told you, switch player moves. We have to switch the player moves every time, either from X or O, from O or X. It depends upon what is the character chosen by the first player. If the first player chooses O, by default we have to keep the second player X. If the first player chooses X, by default we have to keep the value or the character O to the player 2. So it is vice versa. It depends upon what player 1 chooses. Only 2 combinations we have. Either it can be X or it can be 0. So, or O. That is how it works. Then you have a main function where first we are asking. The function starts from here actually. When I execute, you will get to know. Here, what is happening? Player 1 details has been taken. Why? It is for the scoreboard purpose, right? We are displaying the name against the number of winning they have made, right? How many games they have won, right? So player 1 details is taken and enter the name of the player. It will give the output on the output screen. The player will give the name. It is stored. Again, player 2 details is taken. After that, what is the choice of the player, right? Who will choose what? Player 1 chooses X or player 2 chooses X. It depends upon which character is chosen by which player. We have to store that before starting the game. After that, we have to update the scoreboard details, right? With the name, and the by default it is 0 until unless there is no game played. It is by default 0. That is why it is kept as play 1 0 and play 2 0, right? After that we are printing the scoreboard. The scoreboard function gets executed, which I have shown in before actually, right? After that we have game loop for series of tic tac. Why I am telling series? Because if the person chooses to play 10-20 times the same game, it has to go on and on. The loop should be on. So that is why first I showed you single loop, then I am showing you in now how we have to take up the game if they want to play multiple times, right? So here we have turn to choose for which player. It is for you, player 1, whether you want to choose X or O. Then they'll say X, then the game continues. Again, it will ask if once particular iteration is complete, it will ask after declaring the scoreboard, it will ask again this particular block will be represented. If I want to continue the game, it will ask enter 2 if you want to choose O, enter 1 if you want to choose X, right? If you want to quit the game for the first time itself after finishing, then please enter 3 to quit. So these are the conditions which I have put up. So again, you have a try catch block. Why? Because only 3 options are for you. 1, 2, 3. It cannot be 0 nor 4, right? We have to check for the choice of the input what the user has given, right? We are passing that input. If it is having a value error, it will show up wrong input. Please try again later, or try again giving certain values, proper values ranging between 1, 2 and 3, right? After that, you have certain conditions again for choosing what the player will choose, right? So if the player 1 chooses the option 1, what happens? He will get X or he will get O. Depends upon it. If it is 2, again it is O. What I've given here, for 1 it is directly X. Yes, for 1 choice it is given for X. Again, if it is 2, then it is O. So it depends upon it. Like player 1 chooses 1, this part will execute. X part. If player 1 or 2 chooses this particular option 2, this part will get executed, right? After that, you have again option 3. So what are the different final scores we have? So before quitting, it will give you the scoreboard and it will quit. 3 is actually quit. I've given enter 3 to quit, but before quitting, abruptly ending the program, we try to display the final scores and quit, right? Any other choices beyond 1, 2, 3, we put up a default statement here that is wrong choice, try again, right? So that is how it goes. Then in order to store every single program, every single game winner, we will use this particular single game function and we try to store the value who is the winner. And scoreboard will be edited accordingly as soon as the game goes on. If it is one game, it will stop at the one game. If it is 2 or 3 or more, it will be considering all the games that has been won by the respective players, right? So every time we have to choose the scoreboard, I mean winner or the draw game, we have to switch between the players and see who has won how much. So in order to do that, we have to update the scoreboard, which happens in this particular code section, snippet of code, right? So that's about the explanation for this particular tic-tac-toe game where we are implementing using Python language, right? So I'll quickly try to execute in front of you what might be the output. So let's wait. It is trying to connect. So I'm using Google Colab in order to make this program work. I mean, implement this program. So quickly, let's wait for a minute. Yes, we got the output screen. So this is how it will ask. First, it will ask for player details. As I have told you, I'm putting the player name as Ram. Player 2 name, again it is, I'll put second name. So initially it will display the scoreboard as I told you. Ram is at 0, Sham is also at 0. So now Ram is given a chance in order to choose which alphabet or which character they need. Either it is X or O, right? So Ram is choosing 1 for example, right? So it will try to put up, yes, this is the grid how it looks, right? In which place, which box you want to put this X. Ram says I want to put it in 2. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is how it is going. So at the position 2, clicking, what is happening? It will give an option for player turn in order to put up 0, the next player, right? So I'm trying to put that into 3. Okay, again player X turn. So we are taking not the names, by we are taking the character names. Player X means the first person who chose the X as his character. Player O means the second player. We are not choosing their names actually here. We are only recognizing when they are playing with the symbols which they have chose. Don't be confused. Okay, so here player X turn, I have to quickly end this. Now I am just trying to count this particular whether character where it should be placed in order to win the game. So it has to be placed in cell 5. I am trying to make this vertical alignment, right? 1, 2, 3, 4, 5. So I am putting the X in 5th box. So let me check. Yes, it is here now. Now it is the turn for the second player who has chosen 0. I mean O, right? So I'll try to give 1. Fine. So this is the condition. Now there is a chance for the player 1 to win, right? They have to put up their character that is X in 8th box. So I'm trying to put 8. So generally we know that we are the generally we know player 1 is winning the game because I'm making them win. So 8. Yes. So immediately what happens? One of the condition will be true. What might be the condition out of 8 different sets? Let me tell you. It will be 2, 5 and 8. Right? If you quickly go back and check the winner condition out of the all the combinations we have, whereas see, this is the particular combination. It is okay out of all these 8, and the player is being considered, the first player is being considered as a winner, right? So 258. Okay, so let's quickly see. Yeah, see, this is 258. It is satisfying, hence the player 1, that is player who chose the character X, is a winner, right? So the scoreboard will be presented. Ram, that is the first player, won one match. Right now the win number is 1 for Ram. So next the cases will be seen whether you have to continue. If you want to continue, it is the turn of Sham now. Sham wishes to play the game further or quit. Depends upon the second player. Say he wants to quit. So we are quitting the game now. But if you still want to try, okay, let me give a Sham with option 2. So what happens again, where you have to place? I'm placing in 1. Okay, next X turn, player 1's turn actually. Now there he is trying to put up in 4. Let me see. Okay, again player 2's turn. I'm trying to put that particular O value in the place 2. I'm trying to end this game soon, so I'm just trying to give a proper input. I'm not playing a proper game here, game kind of thing. I'm just trying to put up the values to show execution for you people, right? So this is 5. Okay, so now it's turn of player 2, remember, right? So I am giving 3. Actually horizontally it is clear now, 1 2 3. Right, so now the score is equal. Ram won the first game, Sham won the second game. So I'll try to quit, selecting option 3. What happens? Let's see. So this is done. Yes, it will stop giving us the inputs further. If you could see here at the end, it will finally give you the scores, final scores, before abruptly quitting, right? It's better to show the final scoreboard. Final scoreboard we have is Ram has won 1 game, Sham has won 1 game. So that is how it goes. So that's about the implementation for this particular tic-tac-toe game in Python.
So, what is factorial? As I already told you in formal definition, that it is a multiplication of an integer and all integers below it. Now we will seeing about the formula about factorials. So here we are having the formula for factorials. That is nothing. Z factorial is equal to z into z minus 1, z minus 2, and it will go up to 1. Now let's take an example of 5. Suppose if you want to calculate the factorial of 5, so I will write like this, or even I can also write like this. So factorial 5 is equal to 5 factorial. Now I want to calculate 5 factorial, so I will write 5. Here as you can see the formula z, and then z minus 1, that is 5 minus 1 will be 4 into 3 into 2 into 1. So if I multiply all this, then it will be 5 into 4 20, 20 into 3 60, 60 into 2 120. So 5 factorial is 120. This is the way to calculate factorial. Now you might have a doubt that what is the factorial of 0. So factorial of 0 is 1, and factorial of 1 is also 1. Also please keep in mind that factorial can't be negative. Okay, so it must have a positive value and it must be an integer. So we are having two frequently approaches to code factorial programming. The first one is the factorial using loop, and the another one is the factorial using recursive. So let's see factorial using loop. So before calculating the factorial using loop, we will be getting the idea about what is for loop. So let's create a for loop. So for creating for loop, I will write first for, and then we are having 3 stages to create a for loop. The first part is the initialization, second one is the condition, and third one is the updation. So let's suppose that here I am declaring an integer I and I am initializing it to the 0. So this is my first part of the loop. Second part, I am giving the condition. Let's suppose I is less than 5 and the third is the updation. I am giving it increment I plus plus. And inside this loop, there will be a statement, right? So here I will write that printf and then I'll write %d and then I will write I. Okay, so now let's see how this loop exactly works. So the first part is I equal to 0. It will check the condition. So 0 is less than 5, right? So here it will print the value I0. Why I am using here %d? Because here the %d will take the I value. So if I am using here float value, then it will be %f. Similarly for character, it will be a %c. But here I am using integer, so I am here writing %d. So we were seeing the working of loop. So as I told you, the first step will be I equal to 0. After that 0 less than 5, right? So it will print here 0. After that it will go for update. Now the new value of I will be 1. Now is 1 less than 5? Yeah, the condition is still true. Then again it will print 1. After that it will go again for update. New I value will be 2. 2 less than 5, it will print 2. Again for update, we'll get new I value 3. 3 less than 5, we'll get 3. Similarly, it will go for update. Now new value of I will be 4. 4 less than 5, again we are getting 4. Now, once we are getting the value 4, if it is going for update, then 4 plus 1, 5, right? Now we will check the condition. Is 5 less than 5? Is this condition is true? No, this condition is wrong. So my loop will end from here. So there will be no execution once the condition is wrong and loop will be end. Now coming to here, we'll see how to calculate the factorial using for loop. So what I have done here, I have declared an integer n. Why? Because you have to give a value. Suppose that if you want to calculate the factorial of 6, then you have to provide a number, right? So let's say here I have declared a integer n, which name is number, right? After that I will once again declare another variable I, that is I will do for it iteration in loop, and at last I will declare one more factorial variable that is assigned to a value 1. Now what I will do here, I will implement a for loop, and inside this for loop I will give this condition. So this is my logic. Now let's see the logic. How does for loop work? So here you can see that if I am giving n value is equal to 5, okay, so just see the loop. Here I value will be 5 and I is greater than equal to 1 and I minus minus, right? And inside this I have given the logic factorial equal to factorial into I. Okay, so now factorial value initially I have already initialized it to 1, so it will be 1. Now let's see the condition of loop. Here n value I have given 5, right? So I will be assigned to 5. Now what will happen? 5 is greater than equal to 1, right? This condition is true. So here I value will be 5. So now my factorial value will be 5. Okay. Now my I value is 5. Now it will go for the decrement. So 5 minus 1 will be 4, right? Again, is 4 greater than equal to 1? Yeah. So it will print me 4. So now if I am again jumping to this condition, so my new value will be factorial value was 5 and I value was 4. So I will get 20 this time, right? Now again it will go for the decrement. Then I value will be 3. Is 3 greater than equal to 1? Yeah. So once again it will print. So my factorial value was 20 and I value will be 3. Once again it will go for updation. So for updation 3 minus 1 will be 2. 2 greater than equal to 1? Yes. So again my value will be, that is 20 into 3 factorial value was 60. So 60 into 2, 120. Right. Now my I value is 2. Once again it will go for update. So 2 minus 1 is 1. So now it will again check the condition. Is 1 greater than equal to 1? Yes. 1 is equal to 1. So again it will multiply with here. So if we will see the statement, then factorial value is 120 and I value is 1. So new factorial value is 120. Now here I am getting the I value 1. Again it will go for update. The new value of I will be 0. Is 0 greater than equal to 1? No. So our loop will end here. And the factorial value that we will be getting is 120. So this was all about the idea about factorial using loop. Now let's see the practical example. So let's start with the coding part. I will write here hashtag include stdio.h. I will import this library, and after that I will write main function int main, and inside this main function I will declare first variable. So I will write here integer n. N is the value that has to be assigned by the user itself, right? And then I will create I integer that I will use in loop, and one more variable I will create here factorial, and I am assigning the value 1. This is my logic here, right? Factorial is equal to 1 initially I have declared, and after that what I will do, as I told you that n will be assigned by the user, so I will be using here output and input functions. So first I will write here print f, and I will write here enter a number, and after that I will write scanf, and I will write %d inside this %d, and I will also write ampersand, and I will write n here. So here why I am writing %d and ampersand n, so whatever the n value I will assign, it will be assigning to the %d. Okay, so once this thing has been done, after that what I will do, I will create a for loop. Okay, so for creating a for loop I will write for, and I will give, first I will initialize it to the value to the n, I is equal to n. After initializing I will write I greater than equal to 1, then I will write I minus minus. So I will write a statement inside a loop, so I will write the logic. So I will write here factorial is equal to factorial into I. This is my logic, right? And after that, once this for loop is over, I will write once again printf statement, and I will write, so inside printf statement I will write the factorial of %d is %d, and then I will write here n, and then I will write here factorial. So here you can see that I am writing 2 times %d. So the first one is for the n value, and the another %d is for the factorial value. So let's suppose if I am giving n value will be equal to 5, then this 5 will assign here, and whatever the factorial value I am getting, it will assign to here. Okay, after that I will write here this. Let me execute this, and on execution it is asking me to enter a number. So let me give the number as 6. So if I'm writing here you can see that I'm getting the factorial of 6 is 720. So this was all about factorial using loop. Now we will be seeing the factorial using recursion, but before that we have to understand the concept of recursion, that what is recursion. So here as you see in the formal definition, it is written that function calling itself is known as recursion. Now let's understand the logic of recursion. Suppose that here I am having my function, let's say void print, this is my function name, and inside this function I am printing, let's say Gaurav, and after that I am creating main method, and inside this main method I am calling my function. Okay, so as you know that execution will start from main function, so here I am calling my method, that is my function. So if I am calling my function here, it will print Gaurav. So this is a normal flow, right? Now what happens if inside this function I'm writing once again this function again, print. Now what will happen here? Execution will always start from main method. So here when it is calling print function, it will print first Gaurav, and again it will see, yeah, print function is calling itself again. So it will go again here, it will print Gaurav. After printing Gaurav again, it will say, oh, function is calling itself. So again it will print Gaurav. Then again it will see, yeah, function is once again calling itself. Again it will print Gaurav. So like this, it will print Gaurav a number of infinite number of times. So this is the basic concept that I have showed you about recursion. Now how we can implement this recursion in factorial to get a factorial of a number, right? So let's see this. Here, this is a recursive approach logic. So what I have told you that factorial of 0 is equal to 1 and factorial of 1 is equal to 1, right? Now here you can see that int is my return type. I have declared a function whose name is factorial, and inside that I have given a parameter of an integer n, right? So let's say if n is value is equal to our 5, right? Now what will happen here? N value will go here. So it will see the condition is n equal to 0 or n equal to 1, then it will return 1. But this condition is not satisfying. So it will go to the else, right? Else we are having the logic n into factorial n minus 1. So first we are having n value 5. Now it will give us 5 into factorial. What is 5 minus 1? It is 4, right? So here it can see that it is factorial 4 and the function name is factorial int n. So that means recursion is happening once again. So this 4 value will jump here and now it will check the condition. This condition is not satisfying. Once again it will go here. So it will see, oh, again return n into factorial n minus 1. So what the n value that we are having? We are having 4 here and factorial n minus 1, that is 3. Again it will check, oh, factorial 3, function is calling again itself. So 3 will go here. Again it will see. So the new value we will getting 3 into factorial 2. Again function is calling itself 2. N value we are getting, again it will print here 2 into factorial 1. 2 minus 1 is 1. Again it will go 1. So once n value is 1 here, it will see, oh, n is equal to 0 and n equal to 1, right? So it will return the value as 1. So it will return the value as 1. So here we are getting the new value as 1. Now if you multiply it, 5 into 4, that is 20, 20 into 3, 60, 60 into 2, 120. So we are getting the factorial value as 120. So this was the logic, right? Using recursion. Now let's see in a practical to get more clarity that how we can define a function and then inside that function how we can implement recursion using factorial. So now let's see the coding with recursion. So I will write here as tag include stdio.h. This is my preprocess command or library, and then after that I will create my main function. And inside my main function, I will create an integer n. Why I am creating an integer n? So that we can assign a value from user. So to assign a value from user, I will use here input and output. So first I will write here printf. I'll write enter a number. And then after that I will write scanf. I'll write here %d and I will assign the value of n here in %d. So this was all about my output and input, right? Now what I have to do? After this, I have to create a function. So for creating a function in C, we are having 3 steps. First, to declare or initialize it. Second, we have to define it. And then third, we have to call the function. So let me initialize the function. So I will write here, let's say return type is int and function name is factorial. And inside this, I will give an int parameter, integer parameter. Now this was my declaration or initialization part of function. After this, I will define a function. So for defining function, I will write here int, I write factorial, and then I will write int, and inside this I will give the parameter. So which parameter should I give? As I told you, the n value that has to be assigned or that has to be given by user itself, right? So I will write the parameter here n. Now I will implement the logic. So I'll use here conditional statement if n is equal to 0 or n is equal to 1, then we will implement the logic return 1, or else we'll write here return n into factorial n minus 1. So this is my logic of recursion. So I have defined my function here. Now I have to recall it function. I have to want to call it. So as you know that execution will always be start from main method. So I will write inside a main method, I'll write printf, and I will write here the factorial of %d is %d, and then I will write n, the value that has to be given by user, and the factorial, and inside this factorial I will write n parameter, right? So let's understand the logic here. Initially what I have done here, I'll give the n value, let's suppose 5, right? So it will print first enter a number, and then it will assign the value n equal to 5. Now here it will print the factorial of this %d is assigned to n, and this another percentage is assigned to factorial n. So it will print here the factorial of 5 is factorial of 5. So here factorial of 5, instead of n, the value will be 5. So n equal to 5 will be implemented, and now again the same logic will be performing here. Now let me execute this. So if I'm writing here enter a number, I'm writing here 5, then you can see that the factorial of 5 is 120 that we are getting. Okay, so this was all about the factorial using recursion.
So what exactly is this Fibonacci series? Well, when you were in your high school or primary school, you would have come across this series. So let's actually see what it is. So in the Fibonacci series, you have your first two numbers fixed, which are 0 and 1. Now, after that, what happens in the Fibonacci series is when you add the first two numbers or the previous two numbers, you get the third number. As I've told you, the first two numbers are fixed, which are 0 and 1. Now, when you add 0 and 1, you will get the third number, which is 1. After that, when you add 1 and 1, you will get the next number, which is 2. Then again, we follow the same pattern. If you add 2 and 1, you get 3. Again, when you add 3 and 2, you get 5. You add 5 and 3, you get 8. When you add 8 and 5, you get 13. And this is how the Fibonacci series progresses. So this is the simple concept behind the Fibonacci series. You add the first two numbers and you get the next number in this particular series. And this is all about Fibonacci series. There is nothing complicated about it. Now that we've understood what exactly is this Fibonacci series, let's go to Jupyter Notebook and implement this. And over here, I will open a new Python notebook. And let me just give in a heading over here. I will name this as Fibonacci series over here. And first of all, what I'll do is I'll start off by creating a method or defining a method called as Fibo. So I'll just write down def of Fibo. And inside this, I'll just give in one parameter, which is n. So n will tell me how many numbers do I want to see in this Fibonacci series. So if n is 1, then I will get 1 number. If n is 2, I will get 2 numbers. If n is 3, I'll get 3 numbers. So that is how we are defining this function. Now, going ahead, since as I've told you, the first 2 numbers are fixed. So what I'll do is I'll actually have 2 variables over here, a and b. And in the variable a, I will store the value 1. In the variable b, I will store the value 1 again. Now, why am I storing the same number in these 2 different variables? Well, as we progress in this particular code, you will understand this properly. So I've stored 1 in variable a. I've also stored 1 in variable b. Going ahead, as I've told you, if I would want to print only one number, we obviously know that the one number is 0. So here I will check that using if condition. So what I'll do is I will write if n is equal to 1. That is, if I would want to see only the first number in the Fibonacci series, then we all know what that first number is. So I'll just write down print 0. Then going ahead, what I'll do is I'll give an else if. So else if, so instead of, let's say, only the first number, if I would want to see the first 2 numbers, so here the condition would be L if n is double equal to 2. So if I would want to see the first 2 numbers, then we again know what those first 2 numbers are. The first number is 0. The second number is 1. And that is what we'll be printing out. Now, if you would want to see more than the first 2 numbers, then we would have to do something interesting. So this is where our else condition starts. And in this else condition, we will be basically iterating through the numbers. So we will be using an iterative approach using the for loop. So let me just print it over here. What I'll do is I will write down Fibonacci series using iterative approach. And this is what will initially print. Now, after this, we need the first 2 numbers, which are obviously fixed. So what I'll do is I will print 0. So 0 is our first number. And now after 0, our second number is 1. So I will also print a over here. Then after this, we also know our third number, because our third number is 1. Because when you add 0 and 1, it is 1, and that will be our third number. So I have 0, A and B printed. Now after this, I want all of these to be printed with a space. So end of this will be with a space. So end, I'll just give in a space over here. Then I will go ahead and start a for loop. And in this for loop, I'll write down for I in range of n minus 3. Now this is something interesting. Why have I given n minus 3 over here? So let's say if I would want to have a look at the first 6 numbers, then I know that my first 3 numbers are fixed, which are 0, 1 and 1. So 0 I'm printing over here. 1 and 1. So 1 is stored in A, that is what I'm printing. Again, 1 is stored in B, that is what I'm printing. So my first 3 numbers are fixed and I'm printing them out. After that, so when I say n minus 3, I would have to print 3 more numbers, isn't it? Because if the n value is 6, so 3 numbers are fixed, then I need to print 3 more. And that will give me 6 numbers in total. So that is what I've given n minus 3. So let's say instead of 6, maybe I would want 10 numbers. So if I would want 10 numbers, then again, my first 3 numbers are fixed. So again, since my first 3 numbers are fixed, so here it will be n minus 3. So when I say n minus 3, this time it will be equal to 7. So this loop will run 7 times. And that is how this for loop is working. Now, when I come inside this loop, I'll give my first line of code over here, which is total is equal to A plus B. Then going ahead, I will store A inside B. Then I will store total inside A. And then I will finally print out total.
and I would want to end this with a space. So let's understand this logic properly. What is actually happening? So if n is equal to, let's say, 5. So if we take the value of n is equal to 5, this condition is evaluated to false. Then we check this. Is n equal to 5? No, this is also evaluated to false. Then we come inside this else statement. We print out Fibonacci series using iterative approach. Then we print out 0, 1, 1, and then we give a space. After that, this for loop starts, and in this for loop, we would have to print 2 more numbers because 5 minus 3 is 2. So this for loop will go 2 more times. And inside this, you're seeing that total is equal to a plus b. So total is equal to a plus b. So a plus b is 2. So we have 2 stored in total. And now we go ahead. We are storing the value of a in b. So 1 is there in a and I'm storing back 1 in b. So we have 1 in b. Then we will go ahead and will store the value of total in a. We have 2 in total and I am storing 2 in a. So I'll repeat this logic. So here a plus b, 1 plus 1 becomes 2 and we store the value of 2 inside total. Going ahead, I have b is equal to a. So I'm storing the value of 1 in b. Then a is equal to total. So here I have 2 stored in a. Then I go ahead and print out total. So what is there in total? In total we have 2, isn't it? So now after this I'll be printing out 0, 1, 1 and 2 and then I'll give a space. Then since this for loop goes one more time, I'll again enter this for loop. This time total is equal to a plus b. And when I enter the for loop second time, the value of a is equal to 2 and value of b is equal to 1. So now when I say a plus b, it will be 2 plus 1 and we'll be storing the value of 3 inside total. Then going ahead, I will store the value of a in b. So I have 2 in a when I store, and I'm storing 2 in b now. So I have 2 in b. Then I'll go ahead and store total in a. So what do I have in total? I have 3 and I go ahead and store 3 in a. And total I obviously have 3. So I go ahead and print out 3. And this is how I have my fifth number. So now I have finally printed out 0, 1, 1, 2 and 3. Now let's say instead of 5 the number were 6. Then the loop will go one more time, and this time in A we have the value 3 and in B we have the value 2. So 3 plus 2 becomes 5 and you store that value in total. Then again you have 3 in A, you store that in B, and again you have 5 in total, you store that in A. And since I have 5 in total, that is what I'll be printing. So here your sixth number will become 5. So here it will be 0, 1, 1, 2, 3, 5. And this is how we are working with this Fibonacci series using this Fibo method which we have just created. So let me just run this right now. We have successfully created our method called as Fibo. Now I will invoke this Fibo method, and let's say if I given 5 inside this and if I hit on run, so you see that we have printed out Fibonacci series using iterative approach, and I have printed out the first 5 numbers. So you have 0, 1, 1, 2, 3. Now let's say if I would want to see the first 10 numbers, I'll write down Fibo 10, and you see that I have 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And obviously when you are adding them, you'll get the next number. So here if we see 21 plus 13 gives you 34. Now let's say if I given Fibo 1, we are getting 0 because that is our first number. If we given Fibo 2, we get 0 and 1. If we given Fibo 3, we get 0, 1 and 1. And this is how we are working with this Fibonacci series.
Now let's start with the swapping of two numbers. So what's the logic for swapping of two numbers? Suppose if I'm having A is equal to 5 and B is equal to 10. So if you are doing swapping, then your A value will be 10 and now B value will be 5. This is your swapping, right? So what's the logic for swapping? So what I will do here, I will create here a temporary variable, and let's say I am giving the name it to C, and inside this C value, I will assign the value of A, right? Now, inside my A value, I will assign the value B, and inside my B value, I will assign the value C. So what will happen here? Initially, I was having A's value as 5, right? So I will assign to the temporary variable C. So C value will be 5. And here, B value was 10, right? So I will assign it to the A. And then, as I have already written here, B is equal to C. This is the logic. So inside B, I will assign the value of C, right? And C value was already 5. So this is a basic logic. So if you see the final value of A and B, we are getting A is equal to 10 and B is equal to 5. And that's what we want as in output. So this is a simple logic for swapping of two numbers. Let's implement into the coding. So I will write here swapping of two numbers, and I will comment it. Now what I will do, I want the value to be given by the user itself. So I will write here variable A, and then I will write input, and inside this I will write enter a number. And now I will make it as an integer value. So I will write here int input enter a number. Similarly for B value also I will do the same thing. So let me just copy and paste. I will write here B. So as I was telling to you that I will create a temporary variable C, and inside that I will assign the value of A, and then after that inside A I will assign the value of B, and inside B I will assign the value of C, and the swapping will happen. And finally I will write here print. I will write here the value of A is, I will write here A, and print the value of B is B. Now let me execute this. So I will write here comma, and here I will also write comma, and if I am executing it, then it is asking enter a number. So I will write, let's say A is equal to 5 and B is equal to 10, and you can see that after swapping we are getting the A value as 10 and B value is 5. So this is nothing but about a swapping of two numbers. So the next program that we are having is the reversal of a string. So let's understand the logic of reversal of a string. So here you can see that we are having a split method, or you can say split function. So what I will do, I will first create a string, and I will write here great learning, right? So this was my string, right? What I will do now, I will convert this string into a list. So that's why I'm using a split method, and after that I will print it. Okay, and then here you can see that I am writing like this. So this is nothing but we are doing indexing and slicing. So this thing is the starting point. So I will write here start, this is stop, and this is the count. If we are writing 1, that means it will start from here, right? From great. But if we are writing -1, then it will start from the reverse. So it will start from the learning. Okay, your start will start from the learning itself. And here stop, if I am not giving anything, so by default it will go up to the end, right? And in count I am giving -1. So again it means that it will start from the reverse side, learning. So I can also write here, if I'm writing like this also, then also I'm getting the same result as this thing. I will show you in the practical thing. So by default I will be getting this one. Now after that I will be using the string function join. So it will give me the string, and after that I will be getting the string, that is reversal of a string. Now let's see the practical implementation of this. Yeah, so first of all what I will do, I will create a string. So I will write here string, and here I will write great learning, great learning, or I can write welcome to great learning. So I will write welcome to great learning. So this is my normal string, right? And then after that what I will do, I will split this string. So I will write A is equal to string, and dot I will write split. Okay, and then I will print A. So if I'm running it, then you can see that I'm getting a list of a string, right? Welcome to great learning. So this is a list. Now what I will do, I want to change the order. First I will reverse it. So for reversing it, I will write here a is equal to a, and then I will write here -1, and then again colon, and then I will give an empty space, and then again colon I will write, and after that I will write here -1. Okay, and if I'm writing print a, then you can see that I'm getting the string in a reverse order, right? That is learning grade to welcome, but it's again a list, but I want in the form of the string, right? Okay, so what I will do, I will write here final string, you can say that final string. So this is my variable, and now I will write here double inverted comma, and then I will write dot, and I will write join, and inside that I am writing a, right? So you might have a question that why I am giving a double space between double inverted comma, because I want a space between the strings, right? So after this, what I will do, I will just print final string, and if I'm executing it, you can see that I'm getting a string, and that too also a reverse string, learning grade to welcome. So welcome to great learning, if you see from this side. So this is nothing but a reversal of a string. And as I was telling about the indexing and slicing thing, right? So if you're not writing here -1 also, and simply at count itself you are writing -1, then also you will be getting the same output. Why? Because -1 here, if in count, if you are giving -1, then it means that it will take the value from the reverse side, right? So it will take the reverse value from the string. So this was all about reversal of a string. Now let's see what is Armstrong number. So before coming to the logic part, let us understand what is exactly Armstrong number. So I will give you an example first. Let's suppose that 153, this is a number, right? And in 153 we are having how many digits? 1, 2, 3, right? So if I'm writing here 153, and I'm writing first 1, and then if I'm giving to the power 3, then I am writing here 5 to the power 3 and 3 to the power 3. And if 1 to the power 3 is 1, 5 to the power 3 is 125, 3 to the power 3 is 27, and if you add it, it's coming to 153, right? So if it is coming to the same 153, then this will be an Armstrong number. Let's take one more example. Let's say if I'm having 1, 4, 6, 5. So how many digits we are having? N is equal to 1, 2, 3, 4. We are having 4 digits, right? So if I'm writing here 1 to the power 4 plus 4 to the power 4 plus 6 to the power 4 plus 5 to the power 4. So if this thing is equal to 1465, then it will be an Armstrong number, and if it is not equal to, then it will not be an Armstrong number. Okay, so this was the basic idea about Armstrong number. So let's understand about the logic. Suppose I'm taking a number as 1861, right? And here you can see that I'm writing here digit is equal to number. Number is 1861, and I'm writing here modulus operator. So now modulus operator will give me the remainder. So what will be the remainder here? I will getting the digit as 1, right? Now, as you know that I have written the logic here, so it means sum is equal to sum plus digit, and here you can see the 2 asterisk symbol is nothing but this is the power, right? So it will take the power as order, right? So as I told you that what will be the order for here, let's come to the first. So what I will do, the logic I will implement as sum is equal to 0 initially. So my sum will be here 0, and the digit I have already got as 1, right? And the power will be like number of digits. So the number of digits is here is 4, right? So the number of digit will be 4, 1, 2, 3, 4. So it will go to the power of digits. So it will be the 1 to the power 4. So now my sum is equal to 1 to the power 4. Now what I am doing here, I will use floor division operator, right? So floor division operator will give me the whole number. So I am having the number as 1861. So if I'm doing the floor division operator, I will get my number as 186, right? Now what I will do, I will put this condition inside a while loop, right? So while I will write the number is greater than 0, and then once again this is a loop, so it will see, yeah, number is again 186, is positive, then it will go again jump, right? So now this time I will get digit is equal to number. What's my number this time? 186. So if you are doing the modulus of 186, then what's the remainder you will be getting? So the remainder that you will be getting is 6 here, right? Now after that the sum, again I will go to this formula, sum equal to sum plus digit. So now my sum was 1 to the power 4. So it will add, and then again I am having digit. So my digit is 6 and the order is also 4, right? So you can see that now my sum is equal to 1 to the 4 plus 6 to the 4. And now my number was here 186, right? So 186, if we are doing the float division, then how much you will be getting the value? You will be getting the value as 18, right? So you can see that if we are going on this loop, then the sum that we will be getting as final as sum is equal to 1 to the power 4 plus 6 to the power 4 plus 8 to the power 4 plus 1 to the power 4. Now you can see that the sum I am getting right this. So I will put a condition. If sum is equal to the number, then it's an Armstrong number, right? Because the number we have already initialized as 1861. So if the sum is equal to this, then it will be an Armstrong number. So this is the basic logic of Armstrong number. But always remember that I can't directly put number here, right? Because if you see here, I put the logic here, number is greater than 0. So I will make a numbers copy here. So I will assign another variable a, and inside that I will put the number. Because I put the condition number is greater than 0, right? So at last the number will be equal to 0, then only the loop will end, right? So if the number will be equal to 0, so sum can't be equal to the 0, right? So that's why we'll take the copy of this number. Let me show you with a practical example so that you can get a more clarity over this. So now we'll see the practical example here. So first what I will do, I want a value to be given by the user itself. So I will write a variable here, number, and then after that I will write int and then input. Then I will write enter a number. And now after this I will write one more variable, that is sum, and I will assign the value as 0, as I told you in the logic also. Now if I want to calculate the order, so as you read number, if suppose I am giving 1831, so the number of digits will be 4, right? So I want some method so that I can get the order, right? So if I want order, then I have to calculate the length, right, of that integer value. So what can I do? I will write here length, and then I will create a string of this number. Getting my point? So suppose if we are having the number 1831, right? So I have assigned this number into a string. So 1831 is string. And if I'm using length, then it will give me the length of 1831, right? So the length of 1831 with a 4. Now after this, I will write the condition of my while loop, that is while number is greater than 0. And inside this, I will write my logic. So let's take, I will write here digit as a variable, and inside this, I will write number. Number is modulus of 10. So next, I will write here sum is equal to, I will write here sum plus, and then I will write digit. And for the power, I will write here into, that is asterisk into the order. And order way I am already getting from the length of this string of a number, right? So order will be 4 if I am giving the number as suppose 1831. And after that, I will write number is equal to number, and then I will do the float division. So this was my logic, right? Now after that, I will give the condition. So if sum is equal to number, so as I told you that if sum is equal to number, then it will be Armstrong number, right? So let me close this and then write colon, and then I will write print. I will write here Armstrong number. Or else, once again I will write print, and then I will write not an Armstrong number. Now if you see here, I've put the condition number must be greater than 0, right? So when will while loop end? When number will be equal to 0, right? So if I'm giving the here condition, if sum is equal to number, so can sum will be equal to the 0, then can we get the Armstrong number? We can't get it, right? So what I will do, I will create one more variable, copy. You can say the copy of the variable. So I will create a variable a, and then inside that I will assign the variable number. And then here I will put the condition sum is equal to a. And now if I'm executing it, and if I'm writing 153, then it's showing Armstrong number. So let's take one more Armstrong number. As I know that 371 is also an Armstrong number. So let me check it. So if I'm writing 371, so again it's showing Armstrong number. So you can see that this was the logic for the Armstrong number, and in this way we can solve the Armstrong number. So the next program that we are having is how to find a second largest number in a list. So for this, our logic is simple. Suppose that I'm having a list, and this in list I'm having a data type like integer data type. Let's suppose that, and I will write here 29, let's say 27, 5, 15, 2, and then 89. So this is my normal list, right? And if I'm using sort function here, so what does the sorting function will do? It will sort this list, right? So in descending order it will sort. So I will get my new list starting from 2, 5, 15, 27, 29, and 89, right? Now here you can see that I am doing the indexing, right? And here I've written -2. So if I'm writing 1 here, so the indexing will start from here, right? But if I'm writing here -1, that means indexing will start from the reverse order. Okay. So if I'm writing -1, then the indexing will start from the reverse order, right? So -1 will be here, right? So when I'm writing -2, then I will be getting this value 29. And you can see that 29 is the second largest number in the list. So this is the way that I have shown you through the sorting method. We are having multiple ways to solve it, but this is the easiest way that I've shown to you. Now let's see in the practical example. So what I will do first, I will just create a list. So I will write here list 1, and inside this list 1, I will write, let's suppose 34, 5, 67, 89, and then I can write 54, then I can also write 49. So in this way, this is my list. And now I will do the sorting thing, right? I will write here list1 dot sort. So you will see here is already been sorted, right? And now I have to print it to see whether this list is sorted or not. So if I'm writing here print list1, then you can see that this list has been sorted, and the list will be sorted in an ascending order, right? So 5, 34, 49, 54, 67, 89. And I have to find the second largest number. So what I will do here, I'll write print list 1, and then I will write -2. And I'm getting 67. So 67 is my second largest number in this list. So this was all about the finding the second largest number in a list. Now the next program that we are having a pattern. So we can have different types of patterns. So I will show you some patterns. So for pattern programming here, what I've done, I have created a variable whose name is number of rows, and I've inserted a value of 5. And now you can see that I'm using 2 loops, and this is a concept of nested loop. So let's understand the working of loop. So inside this loop, I have put number of rows variable. So it will be equal to 5, right? So for I in range, if you see, then we are having 5. So it means I will take the value from 0, 1, 2, 3, and 4. And inside this loop, what I've written here for j in range I, right? Now let's understand the working for this loop. And as we know that end, this function is used to give space in the same line so that you don't have to jump on the next line, right? So let's understand the concept of loop. So first I value will be 0. Then here I will be getting the for j I value will be 0, right? So if I'm getting 0 here, so it will print nothing, right? So once again it will go here for the I loop. Now it will take the value of 1, right? So once it is taking the value of 1 here, then for j in I, here I value will be 1, right? And inside that I'm writing printing I. So my 1 will be printed here. Okay. Now once again it will go to the loop and it will take the value for 2. So I value will be 2 here. So in the j loop, I value will be 2. So if I'm writing for j in range 2, What does that mean? That j value will be having 0 and 1, right? Because 2 will be excluded. So it will print 2 times, right? So here I have written I 2 times, right? So I will get 2, and here I am giving the space, so I will get 2. And for the next line, I have written this command. So I will be getting my output like this, 1, 2, 2. Now it will take I value 3, this loop, I loop, and once I value is 3, then I am getting for j in range 3. That means j value will be from 0, 1, 2. That means this loop will run 3 times, right? So inside this j loop, I have printed I. So I value is 3, so it will print 3 one time, and here you can see that I have given the space, so it will take a space. So again it will go for 1 and it will print 3, and again for 2 it will print 3, and there will be spaces because I have written here end function. So here it will write 3, 3, 3. So here I have written there print, so it will jump to the next line, and now once again we are going, and this time it will take the value of 4, and similarly for j it will take the value of 4, so it will repeat 0, 1, 2, 3. So I will be getting 4, 4, 4. So in this way actually the pattern works, right? So now let's see in the coding example. So let me write number of rows. I will write number of rows here, and then after that I will write, let's suppose 7 here, and I will write loop for I in range, and then I will write here 7, and I will use the concept of nested loop. So once again I will write for j in range, and then I will write here I, and now I will inside this j loop I will write print I, and then I will write end function. So, and after this once again I will write here print, and if I'm executing it, you can see that I am getting this type of pattern. So let me give space here, and you can see the pattern, right? So this is one pattern. Let me give you another example so that we can find different types of pattern also. So let's see some hash patterns here. So I will write here, I will start with once again the loop. So I will write here for I in range, and I will give here, let's suppose 5, and inside this again I will use the concept of nested loop. So I will write for j in range, and again I will write 5, and inside this I'll write print, and now what I will write here, I will write hash here because I want hash to be printed, and once again I will write here end is equal to, and I'll give a space, and for the next line I will write here print. And if I'm executing this, you can see that I'm getting the hash pattern. So again, the concept is similar here. So I will take the value from 0 to 4, right? 0, 1, 2, 3, 4. And even the j will take the value from 0, 1, 2, 3, 4. So what will happen here? First, here, as you see that I value will be 0, then j value will be here also 0, right? So you can see that I value will be 0, and then j value will be also 0. Then it will print one time, and then after that I value will be 0, then j value will be 1, I value will be 0, j value will be 2, I value will be 0, j value will be 3, I value will be 0, and j value will be 4, right? And after that, in this way it will continue, right? So it's a concept of nested loop, and in this way we can print the pattern of hash. So there are a lot of patterns you can try by your own, and this was the basic idea about the pattern programming. Next program, that is Pascal Triangle. So before coming to the coding part, let's understand what is Pascal Triangle. So as you can see that this is a triangle, right? And inside this triangle, the outside edges will be equal to 1. And if you want to calculate the number, then you will add these two. 1 plus 1 will be 2. Similarly, the outside edges will be 1. And for calculating the number, we will add 1 plus 2, 3. And then 2 plus 1 will be 3. Here once again 1 and 1 will be the outside edge. 1 plus 3 will be 4. 3 plus 3 will be 6. And then 3 plus 1 will be 4. So this is my Pascal triangle, right? And here if you see the logic, let's create a logic for this. So this triangle will be look like this. and then 1 3 3 1, and then it will be looking like 1 4 6 4 1, right? So here if you see that if I'm writing here 11 power 0, I'm getting 1. If I'm writing here 11 power 1, I'm getting 11. If I'm writing here 11 square, I'm getting 121. If I'm writing 11 cube, I'm getting 1331, and similarly 11 to the power 4, I'm getting this number. So this logic will work up to n is equal to 5, where n is the number of terms, right? So we can implement this logic up to 5 terms. Now let's see the logic. So here I'm writing this thing. So this is nothing but to give the space, right? And here I've written this function. So what is the meaning of this thing? This method means that instead of a new line, it will give a space in the same line, right? So that's why I'm writing this. And after that, you can see that I've written here string 11, and this is nothing but this double star is nothing but is used for the power. So that means 11 to the power I, and I value will be taken from, let's suppose if x value is equal to 5, then I will be taken as 0 1 2 3 and 4, like this. So I value will be 0, then I will get 11, and then 11 to the power 1. For I value 2, I will be getting 121. So this is the logic that is implementing. So here I'm having a string, right? So I'm using here map function. So map function will return me the list, and then I'm using the join. So join function is used for the string itself, right? So here you can see that I've given a space, right? So that I can get a space. So now let's see this logic into the practical example. So let's start with the code. I will write first number of rows I can write. So the logic that I've given to you, it will work up to 5 terms or 5 rows. So I will write here, let's suppose take the value 5, and then here I will write. And after this, I will write range for I in range. And inside this range, I will put number of rows. Number of rows. And now what I will do for space, for giving space, I will write here print, and then I will write here into, and then after that I will write number of rows minus of I, and then I will write end to give the space in the same line so that I don't have to jump onto the another line. And then after that I will write once again print, and inside this I will give a space, and then I will write join function. So join, and inside that I will write map, and inside that map I will write string. And now I will implement my logic. So my logic will be, as I told you, 11 to the power 0. So for giving the power, I will write here 11, and then I will write 2 times star star and then I. So this was my logic, and let me execute this. So on execution, you can see that I am getting the output for the Pascal triangle. So this was all about the basic idea about Pascal triangle. So the next code that we are having is the matrix multiplication. So if you want to solve a problem of matrix multiplication, we can have different ways. So here I am implementing NumPy, right? So when we are using NumPy, suppose that if you want to use any one-dimensional thing, then you can go for array. But let's suppose that if you want to go for further, like 2-dimensional or multi-dimensional array, then we have to use NumPy. So NumPy is again a special library that is provided by the Python, used for numerical as well as scientific analysis. Now, here you see that, as I told you, that we are doing the matrix multiplication, right? So always remember that matrix multiplication, suppose M1 is the matrix here and it is having 2, 3. Here 2 is the row and 3 is the column, and M2 is also there. And if I'm writing 3, 4, so 3 will be the row here and 4 will be the column. So always remember the column of M1 matrix must be equal to the row of M2 matrix. So if M1 is equal to M2, that means M1 of column is equal to M2 of row, then only the matrix multiplication is possible, right? So this thing must be same. So here you can see that in A, I am having 1, 4, 5. 6, 5, 4, and then 7, 6, 5. I can write like this, right? So this is my matrix and it is a 3 cross 3, right? And this is also a 3 cross 3. So you can see that the column of the first matrix is matching with the row of the second matrix. That means matrix multiplication is possible. So yeah, here I have imported the library, import numpy as np. You can also write numpy, but why I have written here np, so that I don't have to write a large name as numpy. So here I will just write np dot array, and for b also I will write np dot array, and then we can perform a method np dot. So dot method will multiply these two matrices. Okay, so I will write a comma b. So this is a simple method that we can use for the matrix multiplication using numpy. Now let's see in the coding example. So here I will write here import numpy as np, and after that I will write a is equal to np dot array, and inside this array I will write here, let's suppose 2, 5, 7, and then I will write here 9, 3, 4. Let's take any number, and then I will write b is equal to, again I will write np dot array, and also remember one more thing, that inside array it's a list of a list, right? So here you can see that this is a list, and inside that we are having a list, so it's a list of a list. So I will write here, let's take any number 3, 6, 8, and then I will write here 5, 2, 1. So can I multiply these two matrices? Here you can see that I'm having 2 rows and 3 columns, and here also I'm having 2 rows and 3 columns. So as you know that a column of the first matrix must be same as the row of the second matrix, but it is not matching, right? So I have to write one more here, so that I'll write here, let's suppose 3, 8, 9. Now if you see, we are having 2 rows and 3 columns, and here if we are having 3 rows and 3 columns. Now you can see that the column of the first matrix is matching with the row of the second matrix. Now the matrix multiplication is possible here. So I will write here C, and that I will write here np dot, and inside that I will write a comma b, and I will write then print C. And if I'm executing this, so you can see that I am getting the multiplication of a matrix. But what happens if I remove it? Will I get the matrix multiplication? You can see that it's showing error, right? So this was all about the matrix multiplication.
Now let us very quickly summarize today's video. In today's video, we looked at the introduction to the Python programming language, discussion regarding variables, data type, looping statements, conditional statement with simple examples, demonstration of basic programming examples like prime number, Fibonacci series, leap year, GCD, etc., Tic Tac Toe game building. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.